Hey everyone, welcome to Simplilearn's YouTube channel. Today we will learn about C++ basics. In this tutorial, we will be learning about all the important fundamentals of C++ programming. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update from Simplilearn. So in this C++ basics tutorial, first we will be learning about the basics of C++ programming, that is types, variables, and if-else, etc. Then we will understand how to download and install C++ in Windows 10. After that, we will cover topics like loops in C++, arrays, and functions in C++. Then we will go through object-oriented programming in C++ and concepts of OOPs like inheritance and polymorphism. We'll also learn about pointers, constructors, and destructors in C++. And at last, we will cover C++ enumeration. So without further ado, let's get started. And welcome to this tutorial on C++ basics. So let's jump in and see what's in it for us. So we will be covering today the basics of C++, that is, we will learn how to write your first program in C++, then types and variables in C++. After that, topics like arrays, strings, if-else statements, for loop, while loop, and functions. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So let's start with the introduction to C++ programming. C++ is a popular programming language introduced by Bjarne Stroustrup in the year 1979. The aim was to make a dynamic language that is efficient and has some additional features to C. Initially, it was called C with classes as it was an extension to C language, but later renamed as C++. It is general purpose case sensitive language and it is called precompiled language because it converts the source code directly to the machine understandable code. It is an intermediate level language because it contains both features of high level and low level language. C++ supports the features of object-oriented language like encapsulation, inheritance, polymorphism, etc. It also supports procedural programming and functional programming as well. Now, as we have understood about C++ programming, let's move on to our first program in C++. So the first program for beginners is Hello World program. In this program, Hello World is printed. It is very basic program and in the first part of the program we are including a header file #include iostream. Header files are generally used to import features into the program. Functions like cin, which is used to take the input from the user, and cout, which is used to display the output, are defined in this iostream header file. Here using namespace standard means we are using all the things which are within the standard library. The second part of the program is main function. This is a special function from where the execution of program starts. Inside the main function, we are printing hello world using the cout, which is used to print the output. Return 0 on the next line will indicate the program that nothing will return and program executed successfully. So let's try this hello world program on our code editor, that is VS Code. So let's first of all name the file hello.cpp. So first of all we'll include the header files #include iostream and then namespace standard we'll write using namespace std. Now we'll write the main function, that is int main. Now inside this function we'll print using cout and we'll write hello world. After that we'll write return 0. Alright, now let's try to run this. As we can see, hello world is getting printed over here. So this is how it's done. So now let's move to our next topic, that is types and variables. Coming to types and variables. In C++, there are different types of data type that acts as a keyword, which is responsible to define a variable. First is Boolean data type. This keyword is used when we have two values, either true or false, and these values are used when there are conditions. For example, if the condition is satisfied, then it's true, otherwise it will return false. Next is character data type. This character data type is used when we are dealing with alphabets and symbols, and it is used to hold a single character within the variable. Integer data type. This data type is used for integer values. They can be both positive and negative. Next is float data type. Float is used when we want to store values that are in decimal form. Now, variables. Variables are used with these data types. It is generally used to store values. And this is the syntax to define a variable. First, we will mention the data type and then the variable name of our choice. For example, int is the data type and data is the variable name. Moving to arrays. Arrays are one of the most important and widely used concepts in C++. It can be defined as a collection of similar kind of elements. The elements of array are stored in contiguous memory locations, that is, one after the other. Arrays make it possible to store multiple values of the same data type into a single variable. The syntax to declare an array is first we will mention the data type, then the array name, and after that number of elements inside the brackets. Our next topic is strings. We can define strings as a collection or group of characters. It is basically used to represent text in the program, and we can perform many operations on strings in order to manipulate it. The syntax of string contains a collection of characters surrounded by double quotes. For example, here string is the type, str is the name of the string, and coffee is the value that is assigned to the string. In C++, there are two ways to create a string. First is C-style strings. In C-style strings, collection of characters are stored in the form of arrays. They are basically arrays of type character. The second way is using string objects. We can create string object to hold a string. They are implemented in the standard library, which we must include in the program using #include. Next is if-else statements. If-else are two conditional statements that are generally used when we want to run the code based on some conditions. We run a block of code which is inside if statement only if the condition is true. For example, if the number variable here is equal to 10, then only the block of code will execute and will print the message you got it. Otherwise, it will run the else block and display the message written inside that block, which is not this one. Now, coming to loops. First is for loop. For loop is the repetition control structure that allows us to repeat a block of code for a fixed number of times, instead of repeating the same code again and again. The syntax of for loop has three parts. First is initialization. It is used to initialize the loop. Next is condition, which is used to determine when to end the loop. And last is updation, which is used to update the loop variables. For example, inside the loop I equal to 0 means we have initialized the loop from 0, and I less than 10 means the loop will keep on repeating until I becomes less than 10. That is, it will repeat for 10 times in total from 0 to 9, and I++ denotes that we are incrementing the loop after each iteration by 1. Another type of loop is while loop. While loop are used in C++ when we don't know the exact number of times the loop should repeat. It repeats the statements till the given condition is true. The syntax of while loop is while keyword and condition in the brackets. and the loop will iterate till that condition is true. And once the condition becomes false, then the control passes outside the loop. For example, in this while loop, the condition is number less than 10. That means the loop will keep on iterating till the number is less than 10. That is, till when it becomes equal to 9. And inside the loop, after printing the variable number, we are incrementing the variable because we want to increment the variable number after each iteration. Now, moving on to functions. Functions in C++ are a group of statements that are designed to perform a specific task. It allows us to write a code inside the function, and then we can use that code every time when we need it by simply invoking the function. We can also pass arguments to the function. The syntax of function is type, function name, and then the parameters. Inside the function brackets, we can write the code and we can invoke the function by calling it from the main function. So as we have understood these concepts, so let's move on to our code editor, that is VS Code, to do some examples on these concepts. So here we will do an example in which we will find the number of even elements and odd elements using array, for loop, and if-else statements. So let's first of all make a new file. Let's name this file as basic.cpp. Okay, so first of all we'll include the header files. Now we'll write using namespace standard. Now we will include int main and int main, and here we will declare an array arr, and we'll write and we'll mention the elements 2, 7, let's say 12 and 9. Okay, now first of all we'll initialize the variables. Let's say int even 0, and we'll initialize odd variable with 0 as well. Now we'll write int length because we want to find size of the array, and for that we'll write size of array name, then divide size of array of 0. So now I'll explain this part. Here we have an array which has 5 integers, and since size of an integer is 4 bytes, therefore size of array is 5 into 4, that is 20 bytes. Now int length, we have written int length equals size of array divided by size of array of 0, that is 20 divided by 4, that is equal to 5. So 5 is the size. Here size of array of 0 is the size of element at index 0. We can take any index here, like array of 1, array of 2, or array of 3. So now we know the length of the array. So here we will include the for loop, and we'll start with int I equals 0. We have initialized I with 0. Now I less than length, this one. Here I have written I less than length, that is I less than 5. Okay. Now I plus plus, we are incrementing it. Now we have to use if condition because we want to find the even elements and the odd elements, and for that we have to include if condition. So we'll write if array of I mod 2, that is if an element on dividing by 2 gives 0 as a remainder, then it is even element. So we'll increment the even variable, this which we have initialized 0 will increment over here. Okay, so now in else block we'll write odd plus plus. It means that if this condition is not true, then the odd variable will increment. Alright, now we will print the variables. So we'll write even numbers, and we are printing these outside the for loop so that they don't repeat with the for loop. So that is why we have printed these outside the for loop. Okay, now we'll write the variable even, and L for the new line. Similarly, we'll write odd numbers, the variable odd, and after that we'll write return 0. Okay, so this is the code. So now let's try to run this one. There is some error. Okay, yeah, the spelling is wrong. Yeah. Okay, let's try again. Yeah, here it is. As we can see, even numbers 2, odd numbers 3. We can check it, like even numbers 2, 12. There are 2 even numbers, and 179 there are 3 odd numbers. So in this question we have used array, for loop, and if else. So now let's try some other example. Okay, let's name this as basic2.cpp. Alright, first of all we'll include the header file, hash include iostream. Now using namespace standard, okay, now we will do an example in which we will print the elements from 1 to 20 using while loop and with the help of function. So first of all we'll start with int main, and inside int main we'll simply call or invoke the function by writing the name of the function. This is the name of the function, print function. Okay, so here we are calling this function, and after that return 0 we'll write. Okay, now we have to make this function. Let's create void. Void is the data type, print function is the name, and inside this function we'll first of all initialize I, the variable I, with 1. Now we'll use while loop and we'll write the condition I less than equal to 20. This means that the loop will keep on repeating until I becomes less than equal to 20. So basically it will move from 1 to 20 times. In total the loop will repeat for 20 times. So now all we have to do is we'll just print the I variable, and in order to give some space between each element while printing, so that is why we have used double quotes with a space between them. Now we'll increment I++, so that I will increment after each iteration. Alright, now here we have called this function and it is getting printed inside the function itself. So let's try to run this one. Here we can see this is the output: 1 2 3 4 5 6 7 8 9 10 up to 20. As I have told you, as you have put the condition less than equal to 20, so that is why 20 is also getting printed, because we have used equal to over here. So we have called the function print function, and inside that function we have initialized the variable I with 1, and we have put the condition I less than equal to 20. So that is why the loop is getting repeated for 20 times and I is getting printed inside the loop. And after that we have used increment operator so that the value of I gets updated after every single iteration. So this is the output. So now let's move on to the next example. So let's make a new file and name it as basic3.cpp. So here we will do an example of string and we'll do some push back and pop back operation on it. So first of all we'll include the header file #include iostream, then using namespace standard Okay, now we'll start with int main. Alright, first of all we'll write string data type, then the name of the string s. Here s is the name of the string. Alright, now first of all we'll display a message to enter a string. So okay, enter a string. Now get line, this is the syntax when you want to take the input of a string. So get line cin is used to take the input and s is the name of the string. So this is how we take the input, and now we will print another message saying that you have entered Now here we will print the string s. Next line and L. Okay, now we'll do some operations like s dot pushback. This will add an element at the end of the string. So let's say we want to add y. So we'll write y inside the bracket, s dot pushback, and inside the bracket with single quotes we'll add y. Now we'll display a message saying after using pushback function, we'll print the string. That is, after using the function pushback, the string would look like this. And now we'll use another function s dot popback. It will delete the element from the end. So we'll write cout and we'll display the message after using popback function. Let's write popback only and we'll print the string. Okay, now after that we'll write return 0 and I think it's done, only the spelling is wrong over here. Okay, yeah, now let's try to run this. As you can see the message, enter a string. So let's say I have entered Barcelona. So you have entered Barcelona after using pushback Barcelona y, because we have used y over here. We want to add y at the end of the string. So after using pushback Barcelona y and popback function after that we have used, and we know that it will delete the element from the end. So here we can see there is no y, popback function have deleted the element. So this is our output, and these were some basics examples of C++ basics. It includes the examples of array, for loop, if else, and functions, strings we have covered. And there are some more examples on each of these topics, so I suggest you to please practice them all, and that is how you will get a good understanding on all of these topics. So you can try some more examples on it. How you can install C++ on VS Code and Dev C++. After we are done with the installation, we'll also learn how to run a program on both of these code editors. So we'll start with Visual Studio Code. To download VS Code, let's go to Google and search for Visual Studio Code or VS Code. We'll click on this first link. This is the official web page for downloading the Visual Studio Code. And we'll now click on this Download for Windows blue button. And now we'll click on Download Now. Here it is getting download, and as you can see, thanks for downloading Visual Studio Code for Windows. Once we are done with the download, we can click on this Open folder. Here it is. Now we need to install this file, so we'll double click on this file. And this is the setup wizard. We'll click on this I accept the agreement. And we'll click on next. As we have accepted the license agreement, now we can select our destination folder or we can leave it as it is. But make sure there must be 293.2 MB of free space on that particular disk space. Now we'll click on next. Here we can again click on next. There is no need to change over here. And now you can click on this create a desktop icon button or anyone else as per your choice. Now we'll click on next, and now we'll click finally on install. It is getting installed. It will take some time. Now we can click on this finish button. Launch Visual Studio, we have marked it. It is already marked. So when we click on this finish button, it will launch the Visual Studio Code. So as we can see, this is the Visual Studio Code. So as we have installed VS Code, now we have to configure it so that the C++ programs can run in this code editor. So in order to do that, we need to add some extensions. So we'll click on this extensions button. Now here we will write code runner extension. We'll write code runner, and this is the extension. We'll click on this install, and it is getting installed. Here are some instructions. We can click on Control plus Alt plus N, or press F1 and then select type run code, but we'll deal with that later. Now we'll add another extension, that is C/C++. Here it is. We'll click on this install. Here we can see downloading Visual Studio Windows Debugger. It is getting installed, and I think it is installed now. So as we have added both the extensions, so let's move on and do a program of C++ in this code editor. Okay, so first of all, we'll create a new file. We'll go to File and click on this New File. Now in order to save this one, we can click on Ctrl S, or we can go over here and click on this Save As. Now we can select the location, like let's keep it over here only. Let's name it as visual.cpp. .cpp is the extension which is used when we want to do a program in C++. Now we'll click on this Save button. Now let's do a simple program to check whether the program is running on this code editor or not. So we'll include the header files, #include iostream. Now we'll write namespace standard. Now we'll write int main. Now inside int main we'll display a message, welcome to this video. Okay, now return 0. Make sure to save this after making changes, or you can click on Ctrl S, or you can go to File and click on this Save. So once you have saved the program, now you can run it. We can click on this play button. It will run the code. As we can see in the output, welcome to this video, we can see. Here it is. So it means our program is working. It is running fine. Now let's do another example in which we will take the inputs from the user. So let's make a new file. We'll go to File and click on this new file. Now we'll save as, and we'll write visual2.cpp. Alright, in this program we'll take the input from the user. So start with header files, #include iostream. Our spelling is wrong. #include iostream, after that using namespace standard. Now inside int main, we'll take the inputs from the user. We'll display the message, enter the first number. Now using cin, we'll take the input. We forgot to mention this, declare this n1 variable. So we'll write int n1, int n2, and int sum equals 0. Alright, here we have taken the input of n1, the first number. Now we'll take the input of another number by displaying the message enter the second number. We'll write N2. Now we'll add both of these, N1 plus N2, and we'll display the result. We'll write end line so that it looks good. Alright, now we need to save it. We'll go to File. I'll click on this Save. Now it is saved. Now we can run this program. We'll click on this Run Code. Now in order to write the first number over here, that is, in order to write in the terminal, we have to configure the Visual Studio Code. And to do that, we'll go to File, and we'll now go to Preference, and in the Settings, we'll click on the Settings, and here we will type Run in Terminal. Alright, now we can scroll down, and here we can see Code Runner Run in Terminal. In my VS Studio it is already marked, but you have to mark this if you want to write in terminal or enter the inputs in the terminal. Alright, once you have marked this, you can close it, and then you can Control S, that is save, and then you can close the VS Studio and then open it again. Once you are done, now let's try to run this. So now you will be able to write the inputs, like let's say 4. The first number is 4. Now the second number, let's say 9. On addition it becomes 13, which is the right answer. So these were some configurations that you need to do if you want to run a program of C++ in Visual Studio Code. So as we have understood how to download and configure Visual Studio Code for C++ programs, so let's move on to learn how we can download Dev C++ and run C++ programs in that. So let's go to Google and type Dev C++. This is the first link. We'll click on that. Now this is the green button saying download. We'll click on that to download Dev C++. As you can see, it is getting downloaded. Your download will start shortly. So now we'll click on download now. Now it is getting downloaded. It will take a while. The size of this file is 48.1 MB. So as you can see, the downloading is almost done. So the downloading is complete. Now we'll click on open folder. Here it is, Dev C++ setup. Now we'll click on this setup. We'll click on yes. The setup is loading. So now here we will select the preferred language. It is English. We'll click on OK. Now we'll click on, this is the license agreement. We'll click on I agree. Now we'll click on next. We don't need to change this, I think. The space required is 346.8 MB, and we'll click on next. Now if you want to change the destination folder, you can, but I don't want to change it, so I'll click on install. Now it is getting installed. It will take a while. It's done, and now we'll click on finish, and it is marked. So when we click on finish, it will launch the dev C++. So here we have to select the language. It is English, so we'll click on next. Here again we'll click on next, and now we'll click on OK. So this is our code editor, that is dev C++. So let's write a code. First of all, let's create a file. We'll go to file and go to new, and we'll click on source file. Alright, now we need to save this one, and in order to save this, we'll click on file, then we'll go to save as, and now we'll select the destination and name it as dev.cpp. Alright, now let's start with the header file, hash include iostream. We'll do a simple program over here using namespace std, because we want to check that whether the program is running in this editor or not. Namespace std. Now we'll write int main. Inside int main we'll display a message, welcome to dev C++. Alright, after that we'll write return 0. Now let's try to run this, and in order to run this program we'll go to execute, and now we'll click on compile and run. Here this is the pop-up, welcome to dev C++. As we can see, this is the output. Now press any key to continue, it will close this window. So our output is correct, welcome to dev C++. So this is how you can run a program in dev C++, and our program was also working fine in the Visual Studio Code. So this is how you can download both of these code editors to run the C++ programs.
Loops in C++. So let's begin and see what's in it for you. So we are going to be learning today about while loops, what is a loop, then different types of loops like for loop, while loop, do while loop, then there is nested loop. After that, there are control flow statements like break and continue. But before we begin, if you're new here and haven't subscribed already, make sure to hit the subscribe button and the bell icon for interesting tech videos. So let's start with the first topic, that is while loops. In order to perform a particular task or operation many number of times, we need loops. These are used when we want to execute a block of statement repeatedly rather than just writing those statements again and again. For example, imagine you want to display your name on the screen 50 times. Now to do that, there are two methods. Method 1 is writing your name 50 times by doing the hard code. And method 2 is writing your name once with the loop condition, and your name will be automatically displayed 50 times. Now it is pretty obvious that you would prefer the second approach because you don't have to put effort in writing your name 50 times. Plus, it is easy to write code in few lines. So method 2 is the functionality of loop. It reduces time in writing the code, plus it increases the simplicity. Now let's understand what is a loop. Loops in computer programming is a series of tasks that are used to run some particular code repeatedly until a specific condition is met. Loops tells the computer when to start the condition and when to stop it. Now, this is a basic flow of a loop. After the initialization, the condition is checked. If it's true, then the block of statement will get executed as long as the condition is true. And if the condition is false, the loop will terminate. Depending on the program, different types of loops are used in different times. So let's first see different types of loops. First is for loop, then while loop, then there is do while loop. After that there is nested loop. These are four types of loops in C++. So let's discuss these loops. First is for loop. It is a repetition control structure that is used to iterate a piece of code based on the condition is true or false. If the condition is true, the statement inside the loop body is executed, and once if it returns false, the execution of statement will get terminated. And after every execution of for loop, the increment or decrement parts will update the loop counter. Now let's move on to the while loop. In this loop, the condition is evaluated first. If it's true, then the set of instructions inside the loop body will execute, and this will happen repeatedly until the condition becomes false. And when it becomes false, the loop will end. Now, the main difference is we use for loops when we know the number of times the body of the loop needs to run, whereas we use while loops when we don't know the accurate number of times the body of loop needs to run. Now, moving to the next loop, that is do while loop. This loop is quite similar to the while loop. In this, the loop will execute the set of instructions once before checking if the condition is true. After that, it will repeat the loop as long as the condition is true. That means, in do while, loop body will execute at least once irrespective of the test condition. Now, coming to the nested loop. When one loop is defined inside the body of another loop, then it is known as nested loop. In C++, there are at least 256 levels of nesting, and the flow of execution for nested loop is, first it includes the initialization of variable, followed by condition 1. If it gets satisfied, then it will search for the second condition. If that also gets satisfied, then it will get increment, and when the condition gets satisfied, it will search for the new set of statements, and follows the same flow of execution. Now coming to the control flow statements. First is break statement. It is basically used to come out of the loop instantly whenever a break statement is encountered inside the loop. The control directly comes out from the loop by terminating it. Basically, break statements are used when we are not sure about the number of iterations or we want the loop to end on some condition. Now we will discuss about continue statement. Continue is also a loop control statement. It is used to skip the current iteration of the loop and control of program goes to the next iteration. In other words, if continue is mentioned inside the loop, it skips the current statement and transfers the control to execute the next iteration of the loop. Now, as we have discussed these topics, let's do some examples to understand them better in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we'll make a new file and we'll name that file as loops.cpp. Okay, loops1.cpp. Now here we will do a program in which we have to print the digits from 0 to 10 using for loops. It will be a basic program just to understand it. We'll write the header file #include iostream. Now we'll write using namespace standard. Now here is the int main. Now we'll write the for loop with a for keyword. Inside the for loop, we'll initialize I with 0. Now we'll put a condition I less than equal to 10, which means the loop will keep on executing until I is less than 10. Now we'll put increment I++. Now inside the loop brackets, all we have to do is to print I. so that all the digits get printed. So now let me tell you, here what we are doing is we are just making the loop to run from 0 to 10. As we can see that I have made I 0 to I less than equal to 10. That means loop will move from I 0 to 10. Now let's try to run it. Here we can see all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is our answer, and let me tell you one thing more. To put return 0 after the loop, it's a good practice. Now I'll again run it. The output will be the same, but it's a good practice to write return 0 in the end. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So instead of writing the hard code, we can just use the for loop in this case. It's a basic example of for loop, but you can try some more examples in order to understand it better. Now let's do one example of while loop to understand it better. We'll be doing a basic example of while loop in which all we have to do is to print Happy New Year 11 times. Let's start. First of all, let's name this file loops2.cpp. Now let's start with the header file, that is hash include iostream. Now we'll write using namespace standard. Now here is the int main. Now first of all, we'll declare n equals 0. We'll take a variable n and initialize it with 0. Now we'll put the while condition with the while keyword, writing while n not equal to 11. Here what it means is the loop will keep on executing until n becomes equal to 11. Now here all we have to do is to print Happy New Year so that it will get printed along with the loop 11 times. Handle. Now we'll write n++. We have written n++ so that the loop will keep on incrementing every single time. After that, now we'll write return 0 outside the loop. Now we'll try to run this. So here's our output, Happy New Year 11 times. So this is how it's done. This is again a basic example of while loop, but to understand it better, one must practice some more examples on it. Now let's do one example of do while loop also. Let's make a new file. First of all, let's name that file loops3.cpp. I think the name is already taken. Then we'll write loops4.cpp. Okay, now so we'll write the header file. First of all, we'll write hash include iostream. After that, using namespace standard, now in this program, all we have to do is we have to print the sum of all the digits from 0 to 9. So So let's start. We'll write int main. So now let's first of all declare a counting variable sum and initialize it with 0. Now we will initialize another variable I with 0. Now the syntax of do while loop is do keyword, and now we will add some code inside the body. We'll write sum equals sum plus I. Here what we are doing is we are simply adding sum variable and I variable and storing it to sum variable itself. We are doing this because we want to find the sum. That is why we have to store it in a single variable. Now we will need to increment I, or else loop is going to run forever. Now we will write while I less than 10. We have written I less than 10 because we want to find the sum from 0 to 9. And make sure to put a semicolon in the end in case of do while loop. Now we will print sum in this while loop. We'll write sum is sum variable. Now this loop will keep on executing till I is less than 10. Now in the do while loop, sum is calculated by repeated addition and increment. In each repetition, it is checked whether the number I is smaller or equal to the inputted number. If it is smaller, then the loop continues, but exits the loop if it isn't. After the control exits from the loop, sum is printed. Now let's try to run this code. Here it is. Sum is 45, which is the right answer. This is our output. So this is how it is done in do while loop. So now let's do one example of our last loop, that is nested loop. First of all, we'll name the file loops5.cpp. Now we'll start with the header files. Now using namespace standard, now in this program all we have to do is to print a star pattern of half pyramid form using nested loop. So let's try. We'll write int main. Now let's initialize two variables, that is I and j. Now let's say we want to make a half pyramid of 10 rows. Then it means we need to run a loop which runs for 10 times. So let's write for initialize it with 0, I less than 10, I plus plus. Now here we have written I less than 10. Instead of this, we'll write I less than equal to 10 because we want the 10th row to be printed also. Now we'll print /n in order to insert a new line. Now we'll write another for loop which will decide number of stars in a particular row. So we'll write j equal to 1 because This for loop is for the column section. Then j less than equal to I, which is a row. Then j plus plus. Now we'll print star. Now one more thing, instead of 0 we'll write I equals to 1 because we want to print stars from 1 to 10. So now let's discuss its working. Initially we have I equals to 1, that is the outer loop value. Now for this value a complete run of jth loop is happening, that is j equal to 1 validated by j less than equal to I. Now this condition is used because the pattern which we are gonna build is having increment of star as the number of rows increments. So for I equals to 1, j equals to 1 is executed. Then j plus plus is done, which increments the value of j to 2. Now j equals to 2 failed to execute as 2 is less than equal to 1 is false. Therefore only one star is printed. Again we go to ith loop. Now for I equal to 2, we'll check every value of j which can be executed, that is 1 and 2. Since only two values can be true, therefore 2 stars are printed. Similarly, we check for I equal to 3, 4, 5 and so on till 9, as we have the condition I is less than 10. So now we'll try to run this and check whether the pattern is printing or not. Here it is, half pyramid form using stars with the help of nested loops. So this is our star pattern. We can make some more different types of patterns using nested loops, but we have done only one example in order to understand the concept. So now let's move to our control flow statements and let's do some examples of them. Okay, now make a new file and let's name this file as control1.cpp. Now we'll write the header file and the namespace standard as we have done previously. So let's do it. Hash include ifstream using namespace std. Now here we will write a program in which we have to print the numbers from 100 to 200, like 110, 120, 130 with a gap of 10. But after 150 we will terminate the ongoing loop. Now how can it be done? With the help of break statement. So let's start. First of all we'll write int main. Now we'll take a variable num and initialize it with 100. Now we'll write a while condition and we'll write num is less than equal to 200 because we want the loop to run from 100 to 200. Num less than equal to 200. Now we'll simply display those numbers. Now we'll write an if condition that if num equals 150, then we'll terminate the loop. And for that we have to write the break statement inside the if statement. So let's write if num equals 150, then we have to break the loop. Write the break statement. Now after that we'll increment this by 10. We're incrementing this by 10 because we want the numbers to be printed like 100, 110, 120 like this. That is why we are incrementing it with 10 and not with 1. Now we'll write out of the loop just to be informed that we are finally out of the loop. Return 0. Now we'll try to run this. Here we can see, here we can see 100, 110, 120 up to 150. After that we are out of the loop. This means the code works fine. So this is the example of a break statement. Now after this we'll do another example of continue. So let's start. Let's make a new file and name it control2.cpp. Now we'll write the header files. Using namespace standard. Now in this program all we have to do is to print the numbers from 100 to 90, only excluding 96 from them. Now how do we do it? With the help of continue statement. So let's start. First of all we'll write int main. Now we'll declare a variable num and initialize it with 100. Now we'll write a while condition, while loop, in which we write the condition num greater than equal to 90, because we want the loop to run till it is equal to 90. That is why we have wrote greater than equal to 90. Basically we want the loop to run from 100 till it becomes equal to 90. Now inside the loop we'll write the if condition in order to skip 96. So we'll write if num equals 96, num equals 96. Now we'll use a decrement operator because our starting point is 100, our ending point is 90. That is why we have to use the decrement operator. Now continue statement. After that we'll write value is, and we'll write the variable num. Now we'll write num minus minus. Here we are writing minus minus because we want it to get decrement after printing also. That is why we have written num minus minus after printing num. Now let's try to run this also. Hope it works. Okay, I think there are some errors. So some brackets were missing. And we'll write return 0. Now we'll try to run it. Here it is. As we can see, 100, 99, 98, 97, but 96 is missing. So this is all we have to do in this program. And this is the basic example of continue statement. In order to understand these examples better, you must try more examples on each of these loops and control flow statements so that it will be easier for you all. C++ array. So without further ado, let's get started. So what's in it for you? We will start by understanding why do we need arrays, then what is an array, after that types of array like one-dimension array, two-dimension array, multi-dimension array, and then memory representation, and lastly we'll go through array initialization. So first is need of arrays. We use arrays because it allows us to store similar type of data within contiguous block of memory, and it allows us to iterate through those variables conveniently using indexing. Usually, an array is used to store similar kind of data like marks scored by all the students of a class and record of attendance of all the employees in an organization. Now moving to what is an array. An array can be defined as a collection of similar kind of elements. These are always stored in contiguous memory locations, that is one after the other. The total number of elements in an array is called the length of the array. Now this is the way you can visualize an array. Here each block is capable of storing data values of some type in sequential manner, and each element can uniquely identify by its index in the array. And this is the syntax of array. Int is the data type, array is the array name, and 5 is the size of array. Now there are few types of array in C++. Those are one-dimensional array, two-dimensional array, and multi-dimensional array. So let's first of all discuss 1D array. This is the simplest form of an array. In this array, data items are arranged linearly in one dimension, having single index value to represent data elements. Now this is the syntax of 1D array. Type is the data type, then there is array name, and after that size of array. And this is the example of one-dimensional array. Now coming to its memory representation. Here we can see 2, 7, 4, 8, 1, 6 are the elements inside the memory blocks, and 0, 1, 2, 3, 4, 5 are the indexes. So by using index we can easily access the elements, and once the array elements are accessed, a number of operations can be performed. Here array of 0 means 2 and array of 1 means 7, and so on. As each element is of type int, that is 2 byte, that means the array occupies 12 contiguous bytes because each block contains 2 bytes and there are total 6 blocks. Now coming to the two-dimensional array. In this array, each element is referred by two indexes, that is rows and columns, and they are stored in the form of matrices. The first index shows a row of the matrix and the second index shows the column of the matrix. Now moving to its memory representation. As we can see, this is a 2D array with 3 rows and 3 columns. And we can also say that these are basically 3 1D array containing 3 blocks each, combined to form a 2D array in the form of a matrix with size of 3 cross 3. The horizontal lines depicts rows and the vertical lines depicts columns. And we know that index starts from 0, so first elements get stored at array 0, 0, that is 0th row and 0 column. Then second element is stored at array 0, 1, that is 0th row and column 1, and likewise all the elements are stored in the array. Now coming to the multi-dimensional array. These are defined as array of arrays, that means each element of multi-dimensional array is an array itself. They can have any number of dimensions and it stores the data in tabular form. A two-dimensional array is also a multi-dimensional array. And this is the syntax for a multi-dimensional array. Here type is the data type of array, then array name is the name of the array, and size 1, size 2 up to so on size n are the dimension of sizes. After that, this is the basic example of a multi-dimensional array. Now coming to the next topic, that is array initialization. So there are two ways to initialize an array in C++. First is you can initialize an array when you declare it by including the initial values in braces after the declaration. While declaring, we could use curly braces to set the values inside it. For example, in this array of size 6, the element 2 is at 0 index, 5 is at 1 index, 1 is at 2 index, and so on. If we don't mention the size of array, then the array will only be large enough to hold the elements added within the curly braces. Other than this, we can set the value after the declaration by assigning the element to the array using its index. Like array of 0 equal to 5, here we are assigning 5 to index 0, and array of 1 equal to 7, here we are assigning 7 to index 1, and same goes for the array of 2. Now let's do some examples on array to understand them better. We'll do these examples on our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now we'll make a new file. Let's name that file as array.cpp, array1.cpp. Now we'll do a basic example in which we have to print the elements of array. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard, now we'll write int main. Now we'll start by writing the data type int. Now we'll write the array name, that is, let's say coupon, and now the size of array, let's say 6. Now curly braces. Now inside these curly braces we'll write those elements, let's say 5, 8, 7, 3, 9, 1. So these are those elements, and this is our array declaration. Now here int means the data type, coupon is the array name, 6 is the size of array, and 5, 8, 7, 3, 9, 1 are the elements of array. Now after that we'll write the for loop with for keyword. Now we'll initialize I with 0, I less than 6 because it is the size of array. Now we'll increment I. Now in this loop all we have to do is to print this array. So how do we do that? So let's do cout, and inside the bracket we'll write I. So here we have printed the array inside the loop, and we have put I inside the array bracket. Now the loop will run from I0 to 6, and likewise all the elements from 5 to 1 will get printed. So let's see. Let's try to run this code. So this is our output, 587391. So this is how we can print the elements of an array. And if we want to print a particular element from the array, all we have to do is to write the index number of that element inside the bracket. Let's say if we want to print 7, all we have to do is to print its index number, that is 2. Now let's run this. See, 777. It is because of the loop that from I0 to I6, that is why it is getting printed 6 times. Now if we remove the loop and try to print it, then it will get print only one time. Let's see. Here 7, and this is what we want to print. Now let's do another example. Let's name this file array2.cpp. Now in this example, all we have to do is to do the sum of all the elements of the array. So let's start by writing our header file #include iostream. Now using namespace std, now we'll write int main. Now here first of all we'll declare a variable sum and initialize it with 0. Now we'll declare another variable n, and n will depict the size of the array. So first of all, in order to scan array, first of all we have to scan the size of it. So we'll scan n. Now we'll declare the array. And inside the bracket we will mention n because it is the size. Now we'll write for loop, and we will initialize with I equals 0, I less than n, which is the size of array, and we'll increment I plus plus. We are writing for loop here because we want to scan the array, and as in this array there are more than one element, so that is why we need for loops. So now we will scan the array. We'll write cin, then name of array, and inside the bracket we'll write I. Now here we have written I inside the brackets because we want to take input of elements from I equal to 0 to n, which is the size of array. Now we'll take another for loop. Now here we will write another for loop in which we are initializing I from 0 to n, and inside that for loop we will do the sum of the array. So we'll write equals to 0, I less than n, which is the size. Now we will increment I plus plus. Now inside this for loop we'll do the code, we'll do the logic of adding the elements of the array. We'll write sum. As we know that we have already initialized sum with 0, we'll write sum equals to sum plus array of I. Now for this statement, sum equals to sum plus array of I, we are adding each value in the array one by one into the sum, which is initially 0. When I equals to 0, then the sum will be equal to 0 plus array of 0, and this sum will keep on getting stored inside the variable sum. As our I increments, our sum keeps on storing the addition value. Now we'll print this sum outside the loop. We'll write cout, and we'll write sum is now we'll write the sum variable. Return 0. Let me tell you, return 0 is optional in C++. Basically, return value is exit status of the program and 0 is considered as OK. In C++, compiler includes it automatically, but it's a good practice. Here we forget to write the data type. Now we'll try to run it. So first of all, we'll write the size, like let's say 6. Now the elements of the array, let's say 1, 2, 3, 4, 5, and 6. Now we want to find the sum of these elements. Sum is 21. Let's recheck. 1 plus 2 equals to 3, 3 plus 3 equals 6, 6 plus 4 10, 10 plus 5 15, 15 and 6 is 21. So this is our right answer. So this is another basic example of array. So after this we'll do one example of two-dimensional array also. So let's make a new file and we'll write the header file. Let's name this file as array3.cpp. Now namespace standard. Now we'll write int main. Now we will declare a 2D array of 3 rows and 3 columns with elements inside it. Three rows, and in the second bracket we'll write 3 columns. Now we'll write the curly braces and another curly braces. This is the way to declare a 2D array. Now 2, 7, 9, let's say. Now again curly braces. 1, 3, 8. Because we are creating a matrix of 3 cross 3, that is why there are total 9 elements inside the array. So now we will create a nested for loop where the outer loop I, which is for the rows of matrix, is initialized from 0 to 2. We'll write int I equal to 0. Now I less than 3, I plus plus increment. Now we will write inner for loop j, which is for the column, and we will initialize it from 0 to 2 as well. We'll write for int j equals 0, j less than 3, j plus plus. Now we will print the array. In the first bracket we will mention I, that is the number of rows, and in the second bracket we will mention j, that is number of columns. And in order to add space, we will add space in the output. Now outside the bracket we will mention AND-L. Shift the elements to the next line. After that we'll write return 0. So this is our output, 541279138 in the matrix form. That is why I have used this space to make the output look good, and this AND-L. So this is our output, 541279138. So this is how we can print the elements of a multi-dimensional array or two-dimensional array. These were some basic examples of array, and in order to understand these programs you must practice more examples on it. C++ functions. So let's go ahead and look what's in it for us. First we'll discuss what is a function, then we'll understand why we use functions, then types of functions like built-in function and user-defined function, then function declaration, after that function calling, then function call methods, and at last we have recursion. Also, don't forget to subscribe to our channel and hit the bell icon to never miss an update. Moving on to the first topic, that is, what is a function? Functions are blocks of code that are designed to perform a specific task. It basically divides the complex problem into smaller portions and make the program easy to understand and reusable. And by reusable, it means we can define the code once and we can use it many times. We can also pass data into the functions in the form of parameters. And this is the syntax. First is return type of the function, then we will write function name, then inside the bracket, these are the parameters. Now, let's discuss why we use functions. Functions make the program less complicated because once function is defined in the program, then it can be used over and over again, which reduces the complexity of code. And it helps in avoiding the duplicity of code and it reduces the amount of code. Due to this, we can easily debug and maintain the code. Now, coming to the types of functions. There are two types of functions in C++, that is, built-in functions and user-defined function. Now, let's discuss these functions. First is built-in function. These are also known as predefined functions or library functions. We don't need to define these functions because these are already present in C++ libraries, and the implementation of these functions are also available in library file. And to use these functions, we don't have to write them separately, we simply call them. Now, coming to the user-defined functions. C++ allows us to define our own functions. These functions are created by programmers according to their requirement. This allows a way to wrap a set of statements to perform a specific task, and that group of statement is given a name so that it can be invoked later from any part of the program. Following is the example of user-defined function. Here club is a user-defined function with the return type void, and it is being called from the main function. Now, let's learn about function declaration. Function declaration basically acts as an identification for the function. It informs the compiler about the existence of function's name, the number of parameters in the function, and its return type. These things acts as an identifier for a function. And this is the syntax for a function declaration. First, we will write the return type, then we will write the name of the function. After that, inside the bracket, we will write the number of parameters. For example, in this chess function, int is the return type, chess is the name of the function, and inside the brackets, these are the number of parameters. Although we can write the names of parameters, but names of parameters are not important in the function declaration, only their type is required. Now, let's learn about function calling. In order to use a function, we'll have to invoke or call a function. When a program calls a function, the control of the program is transferred to the called function, and when the called function completes its task, then the control is returned back to the main program. So the functions are called by writing the name of function, and after that writing the required parameters inside the brackets. And this is the syntax. First we will write the function name, and after that we will write the arguments which we want to pass. For example, sum is the function name and a and b are the arguments. Now coming to the function call methods. Now if the function is without any arguments, then it can be called directly, but if there are arguments within a function, then there are basically two ways to call a function. One is call by value and another one is call by reference. In call by value, we pass the copies of values of arguments into the formal parameters of the function. Hence, the original value of arguments remains unchanged and only the parameters inside the function changes. And in call by reference, we pass the reference or address as arguments inside the formal parameters inside the function. So any change inside the function will be reflected to the original arguments because here we are not sending any copies of arguments, but we are sending the address of the variable as arguments. So these were the two methods. Now coming to the last topic, that is recursion. When a function calls itself again and again until a specific condition is met, then it is known as recursive function, and the technique is known as recursion. This enables the function to repeat itself several times and it gives out the result at the end of each iteration. And this is the basic syntax example in which the function name recursion is being called by itself. Now let's do some examples on it to understand functions in a better way. We'll do the examples on our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Now here we will do a program in which we have to do the sum of two integers with the help of function. So let's first of all make a new file, function.cpp. Okay, so let's start. First of all, we'll declare the header files, that is hash include iostream. Now the namespace standard. Now we'll write int main. Now inside int main, we'll declare a variable named s. Here we have declared this variable because we want to store the sum of those two integers in this variable. So we'll call the function, let's name the function as sum, and let's assume the variables to be 5 and 5. Here sum is the name of the function and 5, 5 are the arguments. Now we'll make the function sum. Here int is the return type, sum is the name, and int a, int b are the parameters. So in this function, we'll write the code to do the sum of these two integers, and for that we have to store the sum in a variable. For that, we will now declare a variable c. Now we will write c equals a plus b. Here we are storing the sum of a plus b into the variable c. Now as we know that the return type is int, so we have to return the variable instead of printing it. We'll write return c. Now in the main function, we'll print that variable. We will print the variable s because after the function completes its task of addition, the output will come back to the calling function, which is getting stored in the variable s. So we'll write the result is now we will write the variable s. Let's see. Hope it runs. The result is 10. 5 plus 5 on addition will get 10. Let's write 3 and again try to run this. The result is 8. 5 plus 3 equals to 8. So this is the right answer. Now we will do another example of C++ function in which we have to find the larger number or greater number among two elements. So let's do that. Let's create a new file. Function1.cpp. Now we will include the header files, hash include iostream. Now using namespace standard. Now first of all we'll write the int main. Now the variable n1. Now we will declare another variable n2. These are the two variables among which we have to find the greater number. So we'll display a message saying that enter the first number. Now we'll take the input n1. Now we'll do the same for the other one. We'll write enter the second number. We'll input the second number. Now we have to make a call to the function named, let's say, maxi, and we will pass these arguments n1, n2. Now let's make this function maxi. The return type is void. Maxi is the name. We'll write the variables n1, n2. Now we'll write the if condition because we have to find the greater number among both these elements. So we'll write the if condition. If n1 is greater than n2, then it must print the n1. So we'll also display a message saying that the larger number is n1. If n1 is greater than n2, then we'll display the n1, and if n2 is greater, then we'll display the n2. We'll write the variable n2. So let's see if that runs or not. I think we have to write the first number. Here we can see enter the first number. Enter the first number. So we'll write, let's say, 56, and the second number would be 78. The larger number is 78. So among both the numbers, as we know that 70 is greater than 56, so this is how we can show it with the help of functions. So these were some basic examples of C++ functions. In order to understand it better, you must practice more examples on it.
Why we need OOPS, then what is object-oriented programming, then we will discuss the difference between OOPS and procedural programming, then we'll go through basic concepts of OOPS, and at last we will learn about the benefits of OOPS. But before moving forward, make sure to subscribe to our channel and hit the bell icon to never miss an update. Now let's move on to our first topic, that is why OOPS. Well, there were some limitations in earlier approaches to programming, and OOPS help to fill those gaps. In object-oriented programming, it is easy to maintain the code with the help of classes and objects. And with the help of inheritance, there is code reusability, That is, we don't have to write the same code again and again, which increases the simplicity of the program. Now, let's understand what is object-oriented programming. Object-oriented programming is a programming pattern where the programs are structured around objects rather than logic and functions. In other words, OOP basically focus on objects that are required to be manipulated instead of logic. For example, let us suppose we have made blueprint of a mall, then that blueprint will be a plan that explains what properties the mall should have and how it should look like, etc. But it is just a blueprint of the mall. We cannot go inside it physically as of now. Now the constructors will go through the blueprint and they will construct the mall, and they can make as many malls as they want with the help of that blueprint, and each mall can have its own different shops and showrooms. In this case, blueprint is the class, the mall is the object, and the shops and showrooms inside the malls are data stored in the object's properties. And these are some basic concepts of OOPs. First is classes, then objects, then data abstraction and encapsulation, then there is inheritance, polymorphism, dynamic binding, and message passing. We will learn about these concepts later. First, we will discuss the difference between OOPs versus procedural programming. Procedural programming follows top-down approach. Here, top-down approach means fragmenting a bigger complication into smaller chunks. OOPs follows bottom-up approach, and bottom-up approach means piecing together smaller tasks to give rise to complex tasks. In procedural programming, overloading is not possible. In OOPs, overloading can be done. In procedural-oriented programming, there are no access specifiers. In OOP, they have access specifiers like private, protected, public. Procedural-oriented programming is less secure. OOPs is more secure because of the concepts like abstraction and encapsulation, which are used for data hiding. Now, let's learn the basic concepts of OOPs. First is class. Class can be defined as collection of objects. It is a logical entity. Then there is object. It is defined as an entity that has state and behavior, or in other words, anything that exists physically in the world is called an object. Inheritance can be defined as when one object acquires properties and behavior from its parent class. It provides code usability. Polymorphism. Polymorphism is a combination of two words, poly, which means many, and morphs, which means forms. It is basically an ability to exist in more than one form. Next is abstraction. Hiding the internal details and showing the functionality to the user is called abstraction. Then encapsulation. Encapsulation is the binding of code and data together into a single unit. Dynamic binding. Dynamic binding is the method call at runtime that means which code will execute is unknown until the program runs. Then there is message passing. It is basically a communication that exists between the objects. As we have gone through some concepts of OOPs, now let's discuss some benefits of OOPs. In OOPs, code can easily be reused with the help of inheritance and object. We don't need to write the same code over and over. Second is, with the help of abstraction and encapsulation, certain parts of program can be hidden, and it helps to make a secure system. Third is, maintaining and modification of code is easy in object-oriented programming. Now, to do some examples on the concepts of OOPs, let's move on to a code editor, that is VS Code. Now here we will do a program of inheritance in which we will make a parent class and a child class, and we will call the attributes using object of child class. So let's get started. First of all, let's name the file. oop.cpp. Okay, so first of all we'll add the header files hash include iostream. Now adding namespace standard. Now we will write int main. So we want to create the object of child class. So first of all we'll write the name of class child, that is child. Let's put C capital, child, and now the name of the object ch. So now we will call the attributes using this object. So we'll write first of all display it. So we'll write cout ch dot name 1, which is the attribute. We will declare it later. So basically we want to write both the names of both the classes together, so that is why we are doing like this. We'll write name2. Name1 will be the attribute of the parent class and name2 will be the attribute of child class. So after that we'll write return 0. Now we'll make the parent class and the child class. So first of all let's write class parent. We'll name it as parent. Then we'll write public access specifier. String is the data type. Name1. Let's write Harley. Okay, now it is mandatory to write the semicolon at the end of the class. Now we'll write the derived class, that is child. We will write the colon symbol. Then we will write public name of the parent class, that is parent. So here we are writing the child class is derived from the parent class. Now within the bracket we'll write public, then string the data type, name2. We'll write Davidson. It's a popular bike brand, Harley Davidson. So now we'll write the semicolon over here. Now we'll try to run this. As we can see, Harley Davidson. Here Harley is from the parent class and Davidson is from the child class. So as we can see that we are calling from the object of child class and still we are able to access the attribute of parent class. So this shows that the child class inherits attributes or properties from the parent class. Now as we have done one example of inheritance, so now let's do one example of polymorphism also. Let's name it oop1.cpp. First of all we'll include the header files. --include iostream stream. Now we'll write using namespace standard. After that we'll write int main. Now here we will do an example of polymorphism in which we will make a base class and its derived classes, and inside these classes we will override a function which is common in all of these classes. So let's start. First of all we'll write the name of the parent class or base class, animal, and we'll make an object A. After that we'll write the name of the child class cheetah and its object name is seal, let's say.
Now another derived class dolphin, and we'll name the object as D. Now while making these classes, we'll write a function named speed in all of these classes, inside all of these classes, and now in order to override that function, we'll call them. So first of all, we'll call it by the object of animal, that is a dot speed. Now c dot speed, this is the object of cheetah class. Now d dot speed. After that we'll write return 0. Now let's make these classes. First of all, we'll make the animal class, that is the base class. Animal. Now we'll write the access specifier public. Now we'll write the function void, that is the data type speed. Now we will display a message inside this function. Let's say it displays who is more faster. Who is more faster. Okay, now we'll put a semicolon in the end. Now we will make a derived class, that is dolphin. We'll write class dolphin child of animal class. Okay, so now inside this class we'll write public, and we'll make the same function speed. And we'll display a message saying, as this class is of dolphin, so we'll write I'm faster in water. We'll put semicolon. Now we'll make another child class, class cheetah. Okay, C is capital, cheetah. Public animal. Now here we will write public access specifier, and we'll write the same function void speed. And over here we'll display a message saying that I am faster on the ground. Semicolon. So now as we can see that a.speed is calling this speed function in animal class, c.speed is calling this cheetah function in cheetah class, and d.speed is calling the dolphin speed function in dolphin class. Okay, so now let's try to run this. Okay, the output is here, but it is not in very good form, so let's put /n in the end.
Okay, /n /n. Okay, here it is. So first, who is faster is displayed, then I'm faster on the ground, then I'm faster in water is displayed. So as we know that first of all we have called the animal class, so that is why who is more faster is displayed. After that we have called the cheetah class, and cheetah says that I'm faster on the ground. Then dolphin class, then dolphin says I am faster in water. So here we can see that each of the class have its different implementation for the same function, that is speed, and this is how polymorphism allows us to do a single action in variety of ways. Okay, now let's do one example of abstraction. Let's name it as oop3.cpp. First of all, we'll include the header files. We'll write hash include iostream. Now we'll write the namespace standard using namespace std. Now as we know, abstraction helps in data hiding, so in this program we will make a variable named coupon as private, and with the help of setCoupon function we will try to assign some value to the coupon variable, and after that we will display it. So let's start. First of all, we'll write int main. Now we'll write the name of the class, that is trade fair, and now the name of the object t. Now with the help of this object we will call a function named setCoupon. I would say coupons, and we will pass 50 as an argument to this function. Now we'll display a message coupon, and after that we will call getCoupon method in order to display the number of coupons. So we'll write t dot get coupons and brackets, done. After that we'll write return 0. Now let's make the class and the functions. So let's start. First of all, we'll write class trade fair. Now we'll write an access specifier private and private. Now we will declare a variable coupon, and as I've already told you, we will make this variable as private, so that is why we have used this access specifier as private. Now after that we will write public access specifier to write a function that is setCoupons. And the parameter is c. As we know that we have passed 50 to this parameter, so now we will write the private variable coupon equals c. So here we are basically assigning the value of c to the coupon, that is we are assigning 50 to coupon variable. Now after that we will make another function and we'll put its data type as int because it is returning something. So we'll write int get coupon, and we will return variable coupon. Now as the class ends, we will write semicolon. Now let's try to run this code. There is some error. Okay, we haven't write s over here. Now let's again try to run it. Coupon 50, as I've told you. So here we have assigned 50 to this function, and the variable c is assigning 50 to the variable coupon. Now after that we have used getCoupon function to return the value of coupon, and that is why it is getting displayed over here. So we got our answer, that is coupon 50. And as you can see that in this example we are not allowed to access the variable coupon, but still somehow we have managed to do that with the help of some functions. So this is an example of abstraction, and it helps to increase the security of the program. So these were some basic examples of OOPS in C++. In order to understand it better, we must practice some more examples on it. C++ inheritance. So without further ado, let's get started. So in this session, we will learn about what is C++ inheritance, why do we use inheritance in C++, then we will understand different modes of inheritance, and after that, we will learn about types of inheritance, that is single inheritance, multiple inheritance, multi-level inheritance, and hybrid inheritance in C++. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So, what is inheritance in C++? Just like a child inherits the behavior and characteristics from his or her parents, similarly, inheritance in C++ is a process in which the derived class acquires all the properties and characteristics from the parent class, that is the base class. Derived class is also known as child class, and base class is also known as parent class. Inheritance is one of the most important features of C++ OOPS, that is object-oriented programming. In inheritance, there are two types of classes. The class which inherits the properties and behavior from the base class is known as derived class, and the class whose properties or characteristics are inherited is called a base class. Now, let's understand why we use inheritance in C++. Inheritance is used in C++ because it increases the reusability of the code and it helps in removing the redundancy. To understand it, let's suppose there are two classes, two-wheeler and four-wheeler. Both of the classes contain similar functions like color, brand, and mileage. Now, if we create these classes, we have to create all the three functions in both of the classes. Or in other words, we have to write the same code two times in both of the classes. So instead of writing that code again and again, we can use inheritance and create a parent class named class vehicle. And both of the two-wheeler and the four-wheeler classes will be inherited from this parent or base class. Now with inheritance, we have inherited both the classes from one base class, that is class vehicle. Now we no longer have to write the code again and again, and we can simply write the functions once in the base class, as both of these classes are inherited from the base class vehicle. So as we have understood about inheritance in C++ and why we use inheritance in C++, so now let's go ahead and learn about modes of inheritance. There are three modes of inheritance in C++, that is public mode, protected mode, and private mode of inheritance. So let's start with the public mode. In this mode of inheritance, the public members of base class remains public in derived class, and same goes for the protected members. That means inside the base class, the class members that are public will remain public in the derived class, and similarly protected class members will remain protected in derived class. Now, protected mode. In the protected mode, the public and protected members of the base class will become protected in the derived class. That means the class members which are public or protected in the base class will all become protected in the derived class. In the private mode of inheritance, protected and public members of class will become private in the derived class. So now let's go ahead to the types of inheritance. So there are various types of inheritance in C++, that is single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So let's start with the single inheritance. In this type of inheritance, a single derived class is inherited from the single base class. It allows the derived class to inherit properties and behavior from the parent class. The derived class objects can access the members of the base class, but the base class objects cannot access the members of the derived class. So now let's have a look at the syntax. As we know, this is single inheritance, so there will be only a single derived class and a single base class, and this is how we derive a child class from a parent class. Class keyword, then the name of the derived class, then the colon operator. After that there is an access modifier with the base class. Now as we have understood about single inheritance and its syntax, now let's move on to multiple inheritance. Multiple inheritance. When a class inherits from more than one base class or multiple base classes, then it is known as multiple inheritance. It allows us to inherit properties and characteristics from more than one base class. Syntax for multiple inheritance is class keyword with the name of derived class, then the colon operator and access modifier with the name of the base class separated with comma and the name of another base class. Here we have shown only two base classes, but we can make more than two base classes depending upon our requirement. Now coming to multi-level inheritance. In this type of inheritance, the derived class is inherited from another derived class. That means when a class extends a class that further extends another class is known as multi-level inheritance. For example, if there are three classes A, B, C, and class C is inherited from class B and class B is inherited from class A, then it can be called as a multi-level inheritance. Syntax of multi-level inheritance is as follows. Base class 2 is derived from base class 1 and the derived class is derived from base class 2. These base class 1, base class 2 and derived class are just the names, not a syntax. You can write whichever name you want with the class. Now let's learn about hierarchical inheritance. In this type of inheritance, more than one class is inherited from a single base class. That is, there would be a single base class and multiple derived classes, which have the properties and features same as that of the base class. As we can see in the figure and in the syntax, the derived class 1 is derived from base class, and similarly derived class 2 and derived class 3 are also derived from the base class. So this was hierarchical inheritance, and our next type of inheritance would be hybrid inheritance. The hybrid inheritance is the combination of more than one type of inheritance, and it can be said that it is a combination of multi-level and hierarchical inheritance. In the figure we can see the base class 1 is the parent class of derived class 1 and derived class 1 is the parent class of derived class 3, which makes it multi-level inheritance. But if we look at it in this way, that the base class 1 is the parent class of derived class 1, derived class 2 and derived class 3, then it is hierarchical inheritance, as multiple classes are inherited from a common base class. So we can say it is a combination of more than one type of inheritance or a hybrid inheritance. So as we have understood about inheritance in C++, so now let's go to its practical aspect and do some examples on our code editor, that is VS Code. So this is our Visual Studio Code, and now we will do an example of inheritance. We'll start by doing the single inheritance example, in which we will make a parent class and a child class. And let's start. First of all, we'll create a file, and let's name this file as, let's name it inherit.cpp, So here we will do an example in which we will create two classes, a base class and a derived class, and we'll create functions in those classes. Like we'll create one function in base class and one function in derived class, and using the object of derived class we will access the member of parent class or base class. So let's start. First of all, we'll include the header files, hash include iostream. Now the namespace standard using namespace std. Now we'll create a base class first, then afterwards we'll create the main function. Alright, so let's create the base class. Let's say the name of the base class or the parent class would be beverage, and inside this class let's make the scope public, and now let's create a function as we have said, drinks. So this is a function and we will print something inside this function. So let's say we are printing all drinks are available. All drinks are available. Now we'll write endl. Now we will use semicolon in the end of the class. So this is our base class and we have created a function drinks and we have printed a message, all drinks are available. Alright, now we will create another class which is derived class or child class. We will write class coffee is the name of the derived class, and use the colon operator, public access specifier, and the name of the base class, that is beverage. Alright, now we'll write public access specifier inside this class, and we will create a function in this class also. Like let's say the name of the function would be mocha. It is a kind of a coffee, so mocha, and we will print that mocha tastes good, tastes the best, I would say. Okay, now let's use the colon operator in the end of the class. So here we have created the parent class or base class and this derived class or child class. So now we will create the main function where we'll do the calling. So now we will create the object of child class. So our child class is coffee, and now we will create the object that is C, the name of the class and the object. Okay, now we will use the object with dot operator and call this function that is drinks, and now using the same object we will call the mocha. The spelling is wrong, yeah, now it is right, mocha. So using the object of child class, here we are calling the drinks function which is of the parent class. So let's see if it works or not. Let's save it and now run it. As you can see, all drinks are available and mocha tastes the best. Both of these are getting printed. That means the object of child class is able to access the member of the parent class. So this is inheritance. When the child class acquires or inherits the behavior or characteristics from a parent class or access the members of the parent class. This is an example of single inheritance. So now let's do another example of multiple inheritance. So let's create a new file and name it as inherit2.cpp. Alright, now here we will do an example of multiple inheritance in which we will create two base classes and a derived class. As we know that in multiple inheritance there are more than one base classes to a single derived class. So let's start. First of all, we'll include the header file. Now we'll use the namespace standard, and now we will create a class that is the base class and we'll name it as party. So class party. Inside this base class we will first of all declare the public scope, and now we will declare a variable, let's say meals. So now we will create a function, and in this function we will take the input from the user about the number of meals to enter the number of meals. So let's start void food. This is the function name, and first of all we'll display the message saying that enter number of meals. Alright, now we will take the input and meals is the variable. Now we will use the semicolon at the end of this class. So in this function we are taking the input of the number of meals. Now in the other class, that is another base class, we will take the input of number of drinks from the users, and then in the derived class we figure out the total bill of the party. Alright, now we will create another base class, that is drinks, not drinks, drinks. Alright, now we'll write the public scope, and similarly we'll create or declare another variable drink, and then now we will create a function. Let's say the name of the function is liquor. Alright, now inside this function we will take the input from the user regarding the number of drinks. So we'll display the message enter the number of drinks. So the user will enter the total number of drinks used in the party or consumed in the party. Similarly goes for the meals. Now we will take the input and we'll write drink. Alright, now we have created this liquor function. Now we will use the semicolon at the end of the class. So here we have created both the base classes, that is class party and class drinks. Now we have to create the derived class. So this is an example of multiple inheritance. So we will create the derived class and use the colon operator. Now we will write the public specifier, and the name of the base class, first base class would be party, separated with comma. The second base class would be drinks. Alright, so this is how we can do that. Now inside this class we will first of all create three variables. Let's say int total meals, int total drinks, and int total bill, because in the end we have to find out the total bill. Alright, now inside the public scope we will create a function name as total. Now inside this total function we will write the logic to calculate the total bill. So what we'll do is, first of all write the total meals equals meals into the price of a single meal. Let's say the price of a single meal is 90, so the total product would be stored in total meals. Alright, now we will do same for total drinks, not frinks, equals drink into, let's say the price of a single drink is 60. Yes. Alright, now after that we have to compute or calculate the total bill. Total bill would be the addition of both of these, total meals plus total drinks. So we'll simply do the addition over here, total drinks. So once it's calculated, we'll simply display a message saying that the total bill for the party is, and we'll write the variable that is total bill, where the total bill is actually getting stored. Alright, after this we will use the semicolon. So this is the derived class. Here we have calculated the total money spent in the party. So now we have to write the main function where it all started. Inside the main function, first of all we will create the object of child class. So we know that our child class or the derived class is bill. So bill is the derived class and b would be the object. So using this b, we will first of all call a function, that is food function. So by calling this we will take the input of number of meals. Now we will call another function named liquor. Alright, using this function, calling this function, we will take the number of drinks from the user. Now we will call this total function. So this will calculate the total money spent in the party, and after that let's say return 0. We are calling all of these functions using the object of derived class, and this is where multiple inheritance is going on. So let's see whether it works or not. We will save it and we'll try to run this. Enter number of meals, as we can see. Enter number of meals. Let's say the number of meals would be 20. It was a short party. Then enter number of drinks. 17 would be. So our total bill for the party is 3270, which is the correct answer. So this is how we can do multiple inheritance, and this is a fine example of multiple inheritance. Now let's do another example. So let's name this one as inherit3.cpp. Alright, so here we will do an example of multi-level inheritance, and we know that in multi-level inheritance a single derived class is inherited from another derived class, or in other words we can say a class extends a class which further extends another class. Then it is called a multi-level inheritance, as the name suggests. So we will do example of that. In this example, we will calculate the marks of a student scored by him in 3 subjects. We will calculate the total marks scored by him using multi-level inheritance. So let's do this. So first of all, we will include the header file #include iostream. Then we will write the namespace standard. Now we will create the class, base class chemistry. Alright, in this class, first of all, we will make the public scope and marks1. So here we will take the input of marks scored by that particular child in this chemistry subject. So we'll create the chemistry function void chemistry. It is of same name as that of class. So let's say chemistry marks. Alright, now we will display the marks scored in chemistry. Enter the marks scored in chemistry. Spelling is wrong. Okay, now we'll take the input marks1. So the student will enter the marks. After that, let's put semicolon in the end. Now we'll create another class named physics, which is inherited from chemistry class. That is, chemistry class is its base class, chemistry. Alright, so in this class we will do the same, public int marks2. Now we'll write void physics marks. We'll do the same as we have done in the previous class. So now we will display a message saying that enter the marks scored in physics. Alright, now we will take the input in marks2. Alright, so now we will put semicolon in the end of this class as well. So now we know that this physics class is inherited from this chemistry class. That is, the chemistry class is the base class of physics class. Now we'll do same for maths, like class maths, which is inherited from the physics class. We will write physics. Inside this class as well we'll do the same, and as you can see, this physics class is the base class of maths and the base class of physics class is chemistry. So this is a multi-level inheritance. So in this class we'll do the same, public scope, and now after public scope int marks3 is the variable we have declared, and we will declare another variable in this one like total, because we have to find out the total marks. Now function maths marks. Inside this one we will display the message that enter the marks scored in maths. Alright, now we'll take the input marks3 and we'll write the semicolon in the end. So here we have created all of these 3 classes, which is of multi-level inheritance. As you can see, we have taken the input from the user of its maths, physics and chemistry marks. Now we'll do the total. So we have to do the total inside this class only. So the name would be result function. So the total variable that we have declared is equal to marks1, marks2 plus marks3. So physics, chemistry and maths marks, we will add all of them and then we will display the total. Alright, now this is done. Now we have to go to the main function. Now first of all we will create the object of child class maths. Once this object is created, now we can call the functions, as it can access the base classes. So chemistry marks first of all, then m dot physics marks, m dot maths marks, and then the total, that is result function, m dot result. Then we'll write return 0. So return 0. So here first of all m dot chemistry marks will call this function in the chemistry class. So the user will enter the marks code by him in chemistry. Then this will call physics marks, so the user will enter the marks code by him in physics subject. Then similarly we will maths marks, they will enter the marks of maths. Then we will call the result function. We will do the total of all the marks scored by the student. We will do the total and then we will display that total. So pretty much it's done. Now we can save it, and now let's try to run this one. There are some errors. Alright, that's a silly one. By mistake we have done this. Alright, now let's save it and run it again. Hope it works now. Yeah, another error, marks. Now let's try again. Now it's working fine. Enter the marks code in chemistry. Let's say 80. Physics 80. My maths is weak. Let's say 75. 235. Which is the right answer? 80 plus 75 is equal to 235. And using the object of child class, we have called the functions of all of these base classes. Like we have called this chemistry marks function and this physics marks function, which is of base class. And this was a fine example of multi-level inheritance, and this is how we can do multi-level inheritance. So these were some examples of C++ inheritance. You can try some more examples on it, and these were some decent examples. To understand it better, you can start with some basic level examples, then go to the intermediate level. C++ polymorphism. So let's go ahead and have a look at what we'll be covering today. So we'll start with what is polymorphism in C++, then types of polymorphism in C++, that is compile time and runtime. We'll also study function overloading and operator overloading under compile time polymorphism. And under runtime polymorphism, we will learn about function overriding and virtual function in C++. But before we begin, make sure to subscribe to our channel and press the bell icon to never miss an update from Simplilearn. So what is polymorphism in C++? Polymorphism is an important topic of C++ OOPS concept. The word polymorphism is derived from two words, that is poly, which means many, and morphs, which means forms. So basically it means many forms. Polymorphism in C++ can be defined as when the member function or the object behaves differently in different situations or circumstances. Then it can be called as polymorphism. For example, a mother has different relationships with different family members inside the house. For example, she is a parent to her child, she is a wife to her husband, she is a sister to her brother, and she is also a daughter to her parents. So we can say a mother as a single entity has different behavior among different members. And same goes for polymorphism, where functions behave differently in different situations. Now, let's understand the types of polymorphism. There are two types of polymorphism in C++, that is compile time polymorphism and runtime polymorphism. So let's start with compile time polymorphism. As the name suggests, this type of polymorphism occurs during the compile time, and it is achieved by overloading the function or overloading the operator, that is, by function overloading or operator overloading. So what is this function overloading? Function overloading is a feature in C++ where the functions having the same name but different in terms of parameters or type of parameters can be overloaded. For example, as we can see, two functions with same name func differ in the type of arguments. One data type is double, another data type is integer. So when we make a call to the function with arguments of type double, it will invoke the suitable function, and the same goes for the other one. In example 2, there is a difference in number of parameters among functions. So while calling the function, if we pass 2 arguments, it will invoke the first function, and if we will pass 3 arguments, then it will invoke the second function. Then next is operator overloading. Like functions, operators can also be overloaded. In operator overloading, we can redefine the functionality of the operator. It helps us in redefining the already existing operator. For example, instead of writing sum equals s1.add s2, we can easily write sum equals s1 plus s2. That is, we can redefine the plus operator and use it to add the numbers in the operator function. And we will discuss the syntax of operator overloading in the examples. Now, coming to runtime polymorphism. In this type of polymorphism, the functions are invoked during the execution of program, that is, during runtime. This runtime polymorphism can be achieved through function overriding. So let's understand this function overriding. In function overriding, the function of the base class gets a new definition in the derived class. In this, more than one function has the same name and same type of parameters. The only difference is in the definition of both the functions. That is, functions have different definitions in the parent class and the child class. As you can see in the example, void message function has a different definition in the parent class and in the child class. Both have the same name, but in parent class it is printing hello there, and in child class it is printing nice to meet you. By using the object of the base class or derived class, we can invoke the suitable function. So let's move on to our next topic, that is virtual function. Virtual function is also used to achieve runtime polymorphism. It is a function that is defined in the base class and then is redefined in the derived class. The function is defined using the word virtual in the base class, and the name of the function is same as that of the derived class, having different definitions as shown. It tells the compiler to perform the late binding on the function in derived class. The function call is resolved at runtime and in late binding, and the compiler determines the object type at runtime. With the help of virtual function, we can invoke the derived version of the function in the derived class. So as we have covered the theoretical aspect of C++ polymorphism, so let's go ahead and cover the practical aspect of this topic in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
So here we will make a new file and let's name it as poly1.cpp. Alright, poly1.cpp. So let's save it. So here we will do an example of function overloading, which is used to achieve compile time polymorphism. And we know function overloading is a feature in C++ in which two functions have same name but differ in terms of parameters or number of parameters, or the type of parameters can be overloaded. So let's start. First of all, we'll write the header file #include iostream. Now using namespace standard. Alright, so now we will create a class king, and inside that class we'll do the overloading. So the class name is king, and inside the class, first of all, let's make public scope. Now we'll create a function. Return type is void and the name of the function would be pro. Inside this function, let's say we are passing two arguments, int a and b. Alright, now we'll print both of these arguments or variables inside this function. Alright, and we'll use endl in the end. Okay, after that we'll create another function, and the name of the function is same, that is pro, and but in this case we'll make the arguments like int a int b, int c, int d, and int e. So there are 5 arguments in this function, second function pro. As we know that the name of the function is same, and now inside this function we'll simply add all of these. So a plus b plus c plus d plus e. Alright, once we are done with this, we will use semicolon in the end of the class. Alright, now we'll start with the main function. Inside the main function, we will create the object of king class, king, and the object would be k. With the help of this object k, we will call these functions. As we know, the name of the functions are same. The only difference is in the number of arguments. So I'll call the pro function, which accepts only 2 arguments. So the first pro function will be invoked. So I'll pass 10 and 20. So these 2 arguments will be passed over here. Alright. Similarly, now we'll call the pro function again, but now we'll pass 5 arguments so that the second pro function would be invoked. So let's say I'm passing 12, 23, 20 and 62, 6. These are some random numbers. Alright, now return 0 in the end. Now let's try to run this. I think we are done with this. First of all, let's save it, and now let's try to run this. So this is our output, 10, 20. Let's multiply both of them. It will look good. Let's save it and run it again. As you can see, 200 and 123. So this is our output. 10 into 20 would become 200, and if we add all of these, we'll get 123. So this is our correct output. So this was the example of function overloading, and let's start with another example. So now let's create a new file and name this file as poly2.cpp. Alright, we have saved it. Now here we will do an example of operator overloading. As we know that in operator overloading we give definition to already existing operators, or we can say we can redefine the functionality of already existing operators. So let's start. First of all, we'll include the header files as we have done previously. Hash include iostream, then the namespace standard. So first of all, we'll start with the main function, and inside the main function we will write the name of the class that we will create and the object. Let's say the name of the object is O1, and we'll pass the arguments to the constructor. Let's say the argument is 6 and 8. Alright, then I think we can write return 0, and we'll do the rest afterwards. First of all, we will create the class. So as we know that the name of the class is overload, so let's create it, class overload. And inside this class, inside the private scope, we'll start with the variables. Let's say the first variable is n1, and let's declare another variable n2. Then we will create the public scope. Inside this we will create the parameterized constructor, so it is of same name as that of the class, that is overload. And now as the constructor is parameterized, so int num1 and num2 are the parameters. So when we'll create this object O1 and we'll pass these arguments, so it will go here. And alright, inside this, in the definition of this constructor, we will declare the variable res, and we will assign num to n1. We'll assign num2 to n2, and let's say we'll do the subtraction. Alright, n1 minus n2. Alright, now we will display the result, that is res. So res and then the variable res. After that we'll use endl. Alright, so once we are done with this parameterized constructor, then we will create a operator function. So void is the return type, then we will write operator keyword. This is the syntax of operator function. Then after writing the keyword, we'll write the symbol. Let's say minus is the symbol. Then the arguments, if there are any arguments, then we can put those. Then inside the function, that is in the definition, we can perform whatever the functionality we want to perform. So let's say in this case we'll just make the numbers negative, so we'll do that. Alright, now we'll do the calling part of this. We'll simply use the symbol and the operator, and this is how we'll call the operator function. This is very simple, and after that we have to display the digits as well, as we have made them negative in this part. So we'll create a function display, and inside this function we will display those digits or numbers. So we'll write n1 alright, after this we'll do same for n2, so we'll write n2, then there is endl in the end. Alright, so here we are displaying this. So once we are done with this, the class is finished, so we can use the semicolon in the end, and we have to call this void function as well. So we will write o1.display, o1.display. Alright, we are done. Let's see whether it works or not. Let's save it and check it. So as we can see, the result is -2, that is 6 minus 8 equals -2, that is correct, and n1 is -6 and n2 is -8 because we have made them negative inside this operator function. We forgot to add some space in n2 and n1, so that is why it is looking like this, but the answer is correct, and this is how we can do the operator overloading. In this part we have used the return type, then the operator keyword, then the symbol, and if there are any arguments, then we can pass those arguments, and if there are not, we can put it like this. So this is our example of operator overloading. Let's do another example. So now we'll do an example of function overriding. So let's name this poly3.cpp. So in function overriding, the function of base class gets a new definition in the child class, and when we call the function of the child class using the object of child class, then the function of base class gets overridden. So now let's do the example of this function overriding. I think we have named it wrong. Poly3.cpp. Alright, let's name it 4. poly4.cpp. Alright, now let's save it. Now include the header files. Using namespace standard. Now we'll start with the class parent. So this is the base class and we have named it parent. Inside the parent class we will create a function. For that we'll create the public scope. Inside the public scope we will create the function print, and we will display the message. This is the function of parent class or base class whatsoever. Alright, so this is class parent and semicolon in the end of the class. Now we'll create the child class, child derived from parent class. Name of the class is parent. Similarly, we'll do the public scope and create the function void print. So it is same function as that of the above class, and inside this function we will display this is the function of child class, derived class, let's say. Alright, once we are done with this, semicolon in the end and semicolon in the end of the class as well. Then we can create a main function, and inside the main function we will create the object of child class, child obj. So as we have created the object of child class or derived class, so with the help of this we will override the function of the base class. So we'll write obj dot print, which is the name of the function. So as we have created the object of child class, so it will call the derived class or child class function, and in the end let's say return 0. Now save it and try to run this. This is the function of derived class. So as we have expected, so it is calling the child class function. So this function of the parent class gets overridden as we have used the object of child class and call this function print, which is of same name. So this function which is in the child class gets to print derived class. So this is our output. So now let's do an example of virtual function in C++. Virtual functions are defined in the base class to ensure that the functions gets overridden, and when we use the base class pointer to hold the derived class object or the child class object, the base class pointer will always call the base version of the function and not the derived version. So to solve this problem we use the virtual keyword in C++. So now let's start with it. First of all we'll write hash include iostream. Now the namespace standard. Now we will create the base class, class base, and then we'll use the public scope. Inside the public scope we will create the virtual function. Use the virtual, the return type, then the name of the function, that is print. And we have created this virtual function inside the base class. Now we'll print. This is the function inside the base class as we have done previously in the previous question. This function, this is the function of base class. Yeah, it would be right. Alright, once we are done with this, we'll close the class by using semicolon. Now we'll create the derived class and we'll name it derived from the base class, whose name is base itself. Now here we will use the public scope and we'll create the function of derived class, print function, and we'll print this is the function of derived class. Alright, now we'll use the semicolon to end the class. Now inside the int main function, first of all we will create the pointer of base class, base dereference operator b. So we have created the pointer of base class. Now we will create the object of derived class, derived d. So now we will store the address of derived class object to the pointer of base class. So let's do that. B, which is a pointer of base class, address of operator, the object of derived class. So now we will call the print function using the pointer of base class, and it will print the derived class function because the pointer of base class which we are using to call the functions points to the derived class object. So now let's do the calling part. All we need to do is the pointer and the arrow operator and the name of the function, that is print. After that we can write return 0. Now everything is done. Let's save this and run it. As we can see, this is the function of derived class. Here we can see, so the derived class function is getting called, which we wanted. So this is an example of virtual function in C++. We have used this virtual keyword over here, and using the base class pointer we have called this function, and these were some examples of different topics in polymorphism in C++. You can try some more examples on these topics. It will help you in understanding this topic in a better way.
Pointers in C++. And in today's session we will learn about what is a pointer, reference and dereference operator, then declaration and initialization of a pointer, then there is pointer arithmetic, and after that we'll go through pointers and functions, pointers and arrays, and at last we have arrays of pointers. So hello everyone, this is Harsh Bhardwaj and welcome to the video on pointers in C++. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So let's go to our first topic, that is, what is a pointer? A pointer can be defined as a variable that contains the address of another variable. It basically stores the memory address, which means it points to an address of a particular value. And like a regular variable, pointers have a data type also. Now coming to reference and dereference operators. Reference operator or address of operator is defined as that operator which is used to get the address of the variable. It can be easily obtained by preceding the name of the variable with an ampersand sign. Now, dereference operator. Dereference operator basically returns the content stored in the variable pointed by the specified pointer. For example, if we write *a, then it will return the value of variable pointed by a. Now, let's see how to declare and initialize a pointer. To declare a pointer, first of all, we will write the data type. After that, we will write the name of the variable with an asterisk sign. For example, int asterisk sign a, float asterisk b, char asterisk c. Suppose if we want to store the address into a pointer, then we will write int, that is the data type, then ptr, that is the name of the pointer, with an asterisk sign equals to a variable a with ampersand sign, which means ptr will contain the address of the variable a. Now Moving to a pointer arithmetic. C++ allows us to perform addition and subtraction operations on pointers. A pointer is basically an address, that is, it's a numeric value. Therefore, operations like addition, subtraction can easily be done on pointers. There are 4 types of arithmetic operations that can be used in pointers, that is, increment operator, decrement operator, addition, and subtraction. Each time a pointer is incremented by 1, it points to the memory location of the next element. But if the pointer is an integer pointer, its value on ptr++ would increment by 4 bytes because of the size of int data type. For example, assume an integer pointer with current value of 10. Now after the increment, its value would be 14 instead of 11 because int is of 4 bytes. Now let's learn about pointers and functions. Like a normal variable has an address, similarly every function has an address also. And we can easily access the function using its reference or address, only if we know the address of the function. Function pointers are similar to that of normal pointers. When pointers are passed to the function, the address of actual arguments in the calling function is copied into the formal arguments of the called function. And this is the syntax for a declaration of function pointer. Here int is the return type, and parentheses around function pointer tells the compiler that it is a pointer to function. And after this, they are argument lists. Now, let's discuss pointers and arrays. Arrays and pointers are very closely related to each other, and both of them are objects. When an array gets declared, the compiler assigns a continuous block of memory so that all the elements of an array can be stored in the memory. And C++ treats the name of the array as a pointer that contains the address of first element, which is known as base address. So basically, array name is the base address of the array. And if we have to assign the address of first element of array in a variable x, then instead of writing x equal to &array of 0, we can simply write the name of the array only. Now, moving to the last topic, that is array of pointers. Like in array, we can store similar type of elements. It is same in case of array of pointers. But the only difference is, instead of storing the elements, the address of similar type of element is stored. In other words, it stores the pointers which point to the similar data type. And this is the syntax. First is data type, then name of array with an asterisk sign, then in the brackets it is the size of array. Now let's do some examples in our code editor, that is VS Code.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Here we will do one example of pointer to understand reference and dereference operator. We will print the values of variable and the address of that variable also, and it will give us an idea about reference and dereference operator. Let's start. First of all, we'll make a new file and name this file as pointer1.cpp. So first of all, we will import the header file #include iostream. Now we will include namespace standard. After that, we'll make int main. And now we will declare a variable val and assign it a value, let's say 105. Now we will declare a pointer variable ptr. Now we will store the address of the variable val into the pointer variable. So we will write ptr equals &val. Now we'll display a message. Before printing val variable, we'll display a message saying value is. value of val is. Now let's see what is the value of ptr. For that we will have to print ptr also, and we'll write value of ptr is. Now we will print the pointer variable ptr also. Although the value of val and ptr would be same, but in order to check we will print that also. So we'll write cout value of specific ptr is. Now as we have printed variable val, ptr and asterisk ptr, so now let's check all these values. Let's first of all we'll write return 0. Now let's check all these values. Here we can see value of variable val is 105 and the value of ptr is this. This is actually the address, and the value of pointer variable ptr is 105. As we know that the value of val and the pointer variable is same because we have assigned this value, the address of variable val, to ptr, and then the dereference operator, as we know, returns the actual content of the variable. So that is why the value of variable val gets printed when we print the pointer variable ptr, and the address over here is the address of the val variable which we are assigning to the ptr. So that is why this address is getting printed. Now we'll do another example. Let's name it pointer2.cpp. Now we'll include the header files. Hash include iostream. After that, using namespace standard. So here we have an example of arithmetic operations in C++. So first of all, we'll write int main. Now here we will take 4 variables and 2 pointers. So let's do it. Int num1, num2, int sum equals 0, and int sub equals 0. We'll initialize it with 0. Now we will declare the pointers ptr1, ptr2. So let's take input of the required variables num1 and num2, and after that we'll do some arithmetic operations on them. So let's just write. First we'll display a message. Enter 2 numbers. Enter 2 numbers. Now we'll take the input. After this, we will store the address of num1 and num2 into ptr1 and ptr2 respectively. So let's do it. ptr1 ampersand num1, ptr2 ampersand num2. Now we will increment pointer ptr1 and ptr2. We'll do in a bracket and we'll use dereference operator also. ptr1 plus plus dereference operator ptr2 plus plus. Here we are using dereference operator because we want to increment the value only. And as we can see, we have used increment operator. So by incrementing ptr1 and ptr2, the values of num1 and num2 will increment, and after that we will print those values. So let's do it. Before printing, we'll just print a message after increment. Now we will print ptr1 and line. Now ptr2. Now we will do the sum of these incremented values. So we will write sum equals dereference operator ptr1 plus dereference operator ptr2. Now we will simply print it. We'll write addition and we'll print some variable which we have already initialized as 0 earlier, and we'll write end line. So this will give us the sum of the incremented values of num1 and num2. Now let's talk about decrementing the value of pointers using decrement operator. Here by using this operator, the value of the ptr1 and ptr2 gets decremented. So let's start. We'll write decrement ptr1 minus minus. That is the decrement operator. Now ptr2 minus minus. Now we will write after decrement the values of ptr1 and ptr2. So we'll display a message saying after decrement now we will print ptr1 and ptr2. This will display the values of ptr1 and ptr2 after decrement. And at last we will find the subtraction of 2. So we'll write sub decrement operator ptr1 minus decrement operator ptr2 and cout will display first subtraction. We'll write subtraction, then we'll write the variable sub. Let's see how it. Before that, I think we forgot to mention the dereference operator while printing. We have to mention this because we want to print the values. Dereference operator. And let's put some space over here. Now let's try. Enter two numbers. So let's say we'll enter 4 and 5. As you can see, we have entered 4 and 5. After increment, it becomes 5 and 6. And on addition, it becomes 11. After decrement, it becomes 4 and 5 again. Then 4 minus 5, that is equal to minus 1. So this is the right answer. And this is how it's done. This was the basic example of arithmetic operations in pointers. Now let's do another example. Name this file as pointer3.cpp. Now we will include the header files #include iostream using namespace standard. Now we'll write int main. Now we will do an example of pointer and arrays in which all we have to do is to print an array with the help of pointers. So let's start. First of all, we'll declare a pointer. Now we'll declare an array named RRAY. And let's add some elements inside it. 5, 17, 20, 7, 9, 4, 6. I think these are 7 elements. Now we will assign array ARR to pointer PTR. So we'll write PTR equals ARR. After that, we'll run a loop from I equal to 0 to I less than 7 because we want to iterate array elements. So let's write for loop int I equals 0, I less than 7, I plus plus. Now we'll display using dereference operator with pointer. Because we want to display the values, that is why we have used dereference operator. Now we'll do ptr plus plus. We have used ptr plus plus because we want the pointer to move to the next position after each iteration, and endl will help to print the output in the next line after each iteration. So after this, we'll write return 0. And let's try to run it. I think there is some error. Yeah, namespace. Now let's again try to run it. Instead of array, we have used ARR. Hope it works now. Here it is. 27946. 5, 17, 27, 946. So these are our array elements which we want to print. So this is how we can print the array elements with the help of pointer. So these were some basic examples of pointers in C++.
Constructor and destructor in C++. In this session, we will understand what is a constructor in C++, its declaration, and how a constructor is different from the function. Then, we will cover types of constructors, that is, default constructor, parameterized constructor, and a copy constructor. And then, we will discuss constructor overloading and destructor in C++. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So first is, what is a constructor in C++? In C++, constructors are special functions that are different from normal functions. They are used to initialize objects of a class. Whenever an object is created, the constructor is invoked or called automatically. Even if we do not create a constructor, the compiler automatically creates a default constructor. Now, let's move to the declaration of the constructor. Constructors are the member functions of a class that has the same name as that of the class and it doesn't have any return type. A constructor can be defined inside the class and outside the class as well using the scope resolution operator. The syntax of a constructor is as mentioned. Inside the class, cons, we can see there is a constructor which has the same name as that of class, that is cons, and we can initialize variables inside it. This constructor will be invoked automatically when the object is created. Now let's understand how the constructor is different from functions. There are some differences between constructors and functions. So the first is, constructor doesn't have a return type, unlike function which has a return type. Next is, the name of the constructor must be the same as that of the class, and it is not so in case of function. Third is, whenever an object is created, then a constructor is invoked. And the last one is, function can be a virtual function, but it is not so in case of constructors. So these are some differences between constructor and a function. Now coming to types of constructors. There are actually three types of constructors in C++. That is default constructor, parameterized constructor, and a copy constructor. So let's start with the default constructor. A default constructor is a constructor that doesn't have any arguments inside it. It can either be declared explicitly or can be generated automatically, which means even if we do not define the constructor, then also it is generated by the compiler. For example, here cons is the default constructor. In this case, the name of the class would have been cons. That is why the name of the constructor is cons. Now coming to the parameterized constructor. A parameterized constructor is similar to that of the default constructor. The only difference is we can pass the arguments to the parameterized constructor. The constructor can be overloaded and also be used to initialize elements. Here is an example of the parameterized constructor. Cons is the name of the constructor and n1 and 2 are the parameters of the constructor. Now coming to the copy constructor. A copy constructor is a type of constructor which initializes an object using another object of the class. In this constructor, properties of one object is copied to another object. This copy constructor is invoked when an object is passed as a parameter. If a class has pointers or there is some dynamic memory allocation, then it is necessary to have a copy constructor. Its syntax is as follows. Here cons is the name of the constructor and ampersand obj is the reference of the object. As we have understood all of these three constructors, so let's go ahead to our next topic, that is constructor overloading. Like functions, constructor can also be overloaded, and it is pretty much the same as function overloading. The constructor must have the same names, and the difference in the number or the type of arguments will decide which constructor should be called. Here in the example, we can see two constructors with the same names as that of the class are being overloaded. Here the difference in the number of parameters will determine which constructor will be called. Now coming to the last topic, that is destructors in C++. Just like the constructor, the destructor is also a special function which deletes or destructs the object as soon as the object goes out of scope. It basically deallocates the memory that has been assigned to the variables. The name of the destructor is same as that of the class name with a tilde sign. The destructor doesn't have a return type and it also doesn't take any arguments. And here is the syntax of the destructor. So as we have covered the theoretical aspect of this topic, so let's go ahead to our code editor and cover the practical examples on this topic as well. So this is Visual Studio Code, and here we will do some examples of constructors and destructors in C++. So let's start with default constructor example. First of all, we'll create a new file and we'll name it cons1.cpp. Alright, so now first of all we'll write the header files #include iostream. Now we'll write the using namespace standard. Now we'll start with the main function, and inside the main function we'll create an object. So now we will create an object of a class. Let's say the name of the class is book and the object is B. Alright, let's write this. Now we have to create the class. So let's create the class. Class book, which is the name of the class, and inside the class we will declare a variable which is private. So let's start. Pages is the name of the variable, and we'll make this variable as private. Alright, after this we'll write the public access specifier, and now we will create a constructor, and inside the constructor we will initialize this variable pages. So alright, and make sure to make the constructor inside the public access specifier. Alright, now we'll assign, let's say 250 to this variable pages, that is the number of pages is 250, let's say. Now we will display a message like, let's say the name of the book is the compound effect. It's a famous book, and after that we'll write endl for the next line. Now again we will display a message which will display number of pages. So we'll write number of pages, and now we will write the variable pages. Alright, and after the class we will put the semicolon, and let's try to understand it again. When we create this object B, this constructor will be called, and this variable, that is pages, will be initialized with the value 250. Then this message will be displayed, and then the value of this variable pages will be displayed. As we can see, we haven't passed any arguments to this constructor. It is a default constructor. We have created an object of the class book, and that's how the constructor is getting called. And let's try to run this. Hope it works. Firstly we have to save it by pressing Ctrl and S. Now let's try to run it. As we can see, the name of the book is the compound effect, and number of pages is 250, is that we have initialized it 250. So this is the example of a default constructor. Now let's do another example. Now we'll do an example of parameterized constructor. So let's name this first const2.cpp. Alright, now we'll include the header file #include iostream using namespace standard. Now we'll start with the main function, so we'll write int main, and inside the main function we will create an object of a class, let's say bar. The object of this class would be B, and we will pass the arguments, let's say 40 and 35. Alright, by mistake we have wrote this. Alright, now after that we'll write return 0. Now let's create this class bar. So we'll write class bar, and inside the class we will declare two variables which will be private. So let's say private int, and the name of the variable is drink, and another variable would be people. Alright, now we have to create the constructor. So we'll write the public access specifier, and now we'll create the constructor which is of the same name as that of class, that is bar. And now the parameters would be d and p. So we are passing these parameters, that is 40 and 35, to this constructor, as this is a parameterized constructor. So now we will assign these parameters to the private values, that is drink and people, that is the two variables. So we'll write drink equal d, that is we are assigning the value of d to the variable drink. So, and we will do the same for p variable. We'll assign the value of p to the people variable. Once we are done with this, then we have to compute it or do something about it. So let's say we have to multiply it. So it would be total cash, like the number of drinks into number of people, that how many cash is collected by selling those drinks. So we'll create this variable int total cash. This is a function. Inside this function we will multiply the cost of a single drink with the number of people. So let's say, as the return type is int, so we have to return, we can't display over here. So drink into people, drink into people. Alright, now semicolon in the end, and we have to call this function as well. So let's do that. We'll write cout, and then we will display a message, let's say total cash collected. Then now we will call this function total cash, b.total cash. B is the object and total cash is the function. Alright, after that we have already mentioned return 0. So now save it by pressing Ctrl and S, and let's try to run this. As you can see, total cash collected 1400, and we know 40 into 35 will get 1400. That is the right answer. So as we can see, here we have created this object b and passed these arguments 40 and 35, and this is the parameterized constructor bar. These values are then assigned to these variables drink and people, and then we have called this function b.total cash, this function over here, and the value by multiplying drink into people is 1400. That is 14 to 35 equals to 1400. So this is the example of a parameterized constructor. Now let's create a new file and we'll do an example of constructor overloading. So let's name it first cons3.cpp. So here we will do an example of constructor overloading. So first of all we'll write the header files hash include iostream, then namespace standard, Then again we will start with the main function, and inside the main function we will write the name of the class. Let's say the name of the class would be overload, and the name of the object is O1. So here we will create a parameterized constructor, so that is why we will send two arguments, let's say 20 and 4, and we will create another object overload O2 because we want to do constructor overloading. So we have created O2 object, and here we will pass, let's say, 3 arguments. So we will pass, let's say, 50, 65, 30. In the first object, in the first constructor, we are passing 2 arguments, that is 20 and 4. In the second constructor we will pass 3 arguments, 50, 65 and 30. Alright, now let's write return 0, and now we can create the class. Let's say class overload. Now inside this class, first of all we will create this variable result res. Alright, inside this, after this we will declare public access specifier, and we will create the constructors. The constructor would be a parameterized constructor because we are passing the arguments. So overload is the name of the constructor with an capital O. And we are passing 2 arguments in the first constructor, so int x comma int y. Now in this we will multiply and we will store it in this res variable, so x into y. Alright, after this the second constructor, and in this constructor we are passing 3 arguments, and as we can see the name of both the constructors are same as that of the class, but the only difference is the number of arguments. In this constructor we are passing 3 arguments, and now we will store the sum of all of these 3 variables, x plus y plus z. Once it is done, we will put a semicolon in the end, and now we have to somehow display the result. So we will create a function. Int is the data type, result is the name of the function, and we will simply return the variable res. And now we will call this function inside the main class. So before that we will display a message. Let's say result of multiplication is, right, O1 dot res, O1 dot result, sorry, because result is the name of the function and we are calling the function. After that end line, then we'll write result of addition is, then we'll write O2 dot result and semicolon, and we have already mentioned return 0. So let's save it by pressing Ctrl S, and let's try to run this. There is some error. Okay, this is a scope error. We have to include this function inside this class. So let's say now let's try to run this by, after saving this, let's run it. Alright, by mistake we write this wrong. Alright, now let's save it, and now let's try again. Here it is, result of multiplication is 80 and result of addition is 145, as you can see, and 20 into 4 is 80, and when we add 50 plus 30, 80 plus 65 would be 145. So our result is right, and we have successfully compiled the program and run it. So in this example we are doing the constructor overloading, as we are passing these two arguments to this constructor with same name as that of this constructor, and we are passing 3 arguments to this constructor, and we are not actually calling them, we are just creating the object and passing the arguments. Okay, now let's do an example in which we will use destructor as well. So let's create the new file and name this as cons4.cpp. Alright, now let's include the header files. Now namespace standard. Alright, now we'll write int main. Inside int main we will write the name of the function. Let's say the name of the function is formula1 and f is the object. And now we will pass the parameters, let's say 370 and 4. Here we are passing the speed and the pickup of a particular car, and let's make it f instead of d. So f is the object and formula1 is the name of the class. After that, for now, let's say return 0, and now we will create a class formula1. We'll declare 2 variables which are private, int speed and int pickup. Now we will create a constructor which is parameterized. Before that we will use public access specifier, and now we will create this constructor formula1, and the parameters are int s, int p. Now inside it, first of all we'll display a message saying that this is a constructor. Alright, after that we'll write endl. Now we will assign the parameters to these variables. We'll assign the value of s to speed and the value of p to pickup. Alright, after that we'll make a function display, and we can display inside this function as the data type is void, and so we'll write speed is, then we'll write the speed variable, and endl as well. Then we will write pickup is pickup variable, then endl. Alright, now we can create a destructor. We'll use tilde sign, then formula1, which is the name of the constructor. Then here we'll write a message so that we get to know that we are inside the destructor. So we'll write formula1, inside it we'll write this is a destructor. And the sign is, here it is. Now we'll write semicolon after the class. And so first of all, as the object is created, the parameterized constructor is called. 370 and 4 would be assigned to these variables, speed and pickup. And then using the function, here we will call this function display. So we'll write f, which is the object, dot display, which is the name of the function, and that's it. Then once the values are assigned, then these values will be displayed when this function is called using the object f. And then this is a destructor is called as the destructor is called in the end of the function when the scope ends. So when the scope of class object is ended, then this is a destructor is displayed. That is why we have displayed this message. So after saving it, let's try to run this. Here we can see this is a constructor. First this is getting printed, then speed is 370, pickup is 4, and this is a destructor, as we can see, is getting printed in the last. And if we just cut it over here and just paste it here, and we can just paste it over here and save it, and let's try to run this again. There's a variable by mistake we have wrote. Alright, now save it and run it again. As we can see, this is a constructor, speed is 370, pickup is 4. This is a destructor, it is again getting printed in the last. So this shows that the destructor deletes the object as soon as the object goes out of scope, that is in the last. So these were some examples of constructors and destructors in C++. You can try some more examples on it. It will help you in understanding this topic in a better way. C++ enumeration. So let's go ahead and have a look at what we'll be covering today. First is why enumerations are used in C++. Then we'll understand what is enumeration and its syntax, and after that we will learn how to use enums with flags. But before we begin, make sure to subscribe to our channel and hit the bell icon to never miss an update. So first is why enums are used in C++. Enums are short for enumerations. These are basically used when we have some set of possible values and we have to select one out of it. For example, suppose you are the shop owner and you have 4 types of coffee in your coffee machine. That is cold coffee, hot coffee, black coffee and mocha. And you don't want the trouble of customer putting any other coffee name in the machine which is not there. Then in situations like these, enumerations are used. Because in enumerations we have to choose from predefined values, and it is also helpful for documentation and readability purpose. Now let's understand what is enumeration. Enum or enumeration is a user-defined data type in which a set of values are specified for the variable and the variable can take out any value from the set of values. And it is also a way to use integers to represent values. We can assign values to enum, but if we do not assign any value, then the compiler assigns value to them starting from 0. Coming to its syntax, which is enum, that is the keyword for enumerated type, then enumerated type name is written, then under brackets possible values of type enum are written. For example, here enumeration name is player and values are Ronaldo, Salah, Messi, Neymar, which are the names of players. In this example, by default, Ronaldo is 0, Salah is 1, Messi is 2, and Neymar is 3. Because we know by default compiler assigns them value which start from 0 and so on. But we can change these default values by assigning values to them. Like here, Ronaldo's value is now 4, Salah's value is 2, Messi's value is 8, Neymar's value is 1. Now, let's have a look at an example in which we will print the default value of months. So in this example, we have enum name as months and enumerated values as January, February, March, and so on. And in order to access these values, we have written enumeration name and after that the variable. As we can see inside main function, m is the variable and its type is months. Now here we have assigned the month March to the variable m, and then we are printing the variable m plus 1. Here plus 1 will print the value next to the month March, that is 3, and similarly if we write plus 2, then it will print the one next to it, that is 4. These values are default integer values. After printing the output, value is 3 because we have printed m plus 1 where m is 2 and plus 1 makes it 3. Now let's understand how to use enum with flags. In this example, we will choose a mobile having any of the two features among 3. Here the name of enumeration is mobile and its enumerated values are battery capacity, camera quality, large storage, and we have assigned values to them 1, 2 and 4 respectively. And because we are doing this example of enums with flags, that is why we are using integer values of power 2, because it avoids the overlapping. Inside the main function, we are using bitwise OR operator because we want to choose the mobile having both camera quality and large storage capacity. And we know that bitwise operator adds the binary of two integers. So the value of camera quality is 2 and value of large storage is 4. When we use a bitwise OR operator in between these two features, so it will add up their binary, giving the decimal number as 6. So the output 6 is showing both the camera quality and large storage are used. Now let's do some examples of enumeration in our code editor, that is VS Code. Okay, now let's make a new file and name the file as enum.cpp. In this example, the enumeration name will be captain and the enumerated values will be the team members, out of which we will select one member as captain. And with if condition, we will verify if he is the selected captain or not. It will be a basic example. So first of all, let's write hash include iostream. Now we'll add the namespace standard. Okay, now we'll write enumeration enum captain, which is the name of the enumeration type, and now we will write the enumerated values, which is let's say Avi, Sid, Robbie, Sammy, and Jake. These are the team members. Now we'll write int main. Now here we will first of all write captain, which is the name of the enumerated type. Then we'll make the variable out of it, cap. And let's say Avi is the captain. So we'll write Avi. Now here we will write if condition. We'll write if cap equal to AVI, then we'll display our captain is AVI and its value is whatever the value. AVI's value here is 0, so we'll display that. So we'll write our captain is AVI and its value is, then we'll write AVI. As we know that AVI is at first position, then its value would be, default value would be 0. Okay, so here we will write endl. Now in else, here if we put Sid, Robbie, Sammy, Jake as captain, or if we declare them as captain, then this message would be declared, which we will be writing in else. So the message would be he is not our captain. Then over here we will write return 0. Okay, now let's try to run this. Our captain is AVI and its value is 0. Because here captain we have declared AVI, so that is why this is printing. If we write, let's say, Sammy over here, then it will print the else part. He is not our captain. And if we write Jake or Sid, then also it will print the same. He is not our captain. Only in case of AVI, it will print our captain is AVI and its value is AVI's value. So this was the basic example of enumeration. Now let's move on to another example. Now let's make a new file and name it as enum2.cpp. Okay, now we will add the header files #include iostream and using namespace standard. So here we will do an example in which enumeration name will be supercars, and to the values we will assign some integers to them, which will be the speed of those cars, and then we will compare them using comparison operator in terms of speed. So we will write enum, the name of enumeration, that is, let's say, supercars. Okay, now inside the bracket we'll write the name of the cars, which are the values, and we will assign some integers. These integers are actually speed of these cars. $268, then Valkyrie, speed is 240. Now Roadster 250. Okay, now as we have created the enum, now we will start with int main. So we will write the enumerated type name supercars. Now the variable speed 1, because we want to create two variables in order to compare them. So first we will create speed 1. Now again speed 2. Now we will assign the two cars that we want to compare to these variables. So speed 1 will be Valkyrie, and speed 2 would be Roadster. Okay, now we will write the if condition, and inside the if condition we will compare the speed of these two cars. So we will write speed 1. If speed 1 is less than speed 2, okay, then we will print that it's a win for Roadster, because speed 2 is Roadster and speed 1 is Valkyrie. So we'll write it's a win for Roadster. With the speed, we'll also write the speed with the speed of this speed 2 will display the speed of Roadster, that is 250. Okay, now else condition. So here we will write it's a win for Valkyrie. With the speed of, here we will write speed 1. Okay, now we have to write int main, but before that we will write the bracket which we forgot to mention. Return 0. Okay, I think it's done. Now let's try to run this. Here we can see it's a win for Roadster with the speed of 250. As we know that the speed of Roadster here is 250 and the Valkyrie speed is 240. So when we compare it, speed 2, that is Roadster, wins because Roadster is 250. So this was the second example. Now let's do one last example. Let's name this. Okay. enum3.cpp. We'll write hash include iostream. Now namespace standard. Now in this example we will see how to use switch statement with the enumeration. Okay, so first of all, inside int main we will write enum. Color is the name of the enumeration type. Then we'll write the values: red, blue, green and yellow. These are the values. Now here we will use switch statement, but before doing that we have to assign one color to a variable. So first of all we have to create that variable, and in order to create the variable we will write the enumeration type name color and then the variable name select. Now we will assign one color from the above colors. Let's say yellow. Now in switch statement we will write, first of all we will write switch statement switch, and we will pass here the variable, that is select. Basically we are passing yellow because yellow is assigned to the variable select, and that is why it is getting passed. So now case 1, that is case red. First of all we'll write the case red with a colon in the end. Now we will print that it is red. Now we'll write the break statement. Break statement basically ends the case or terminates the case. So after that, the second case, that is case blue, colon. Now here we will print it is blue, and similarly break statement. We'll do same for all of these colors, green and yellow also. And switch statement will help us to find which color is passed and will display the message of that color. So here we will write green, it is green, break statement. Now case yellow, now we'll write it is yellow. Now here we'll write break. Okay, now at last we have to write return 0. Now as we know that we have passed a particular color to the variable select, and select is the expression, and switch statement will help us in comparing the variable select value to the value of different blocks, and one which matches that particular block will execute. Okay, now let's try to run this one. Here we can see it is yellow is being printed, which is the right answer because we have passed the color yellow to the select. That is why only the case yellow output is being printed. So this is how you can use switch statement with the enumeration. So these were some basic examples of C++ enumeration. You can try some more examples on it in order to practice it. So these were some important topics of C++ programming, and with that we have come to the end of this video. If you like this video, please give it a thumbs up. I hope it really helped you all. Thanks for watching, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.